Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Are you aware that majority of corporate level applications are programmed in Java? If you are new to Java and have been hesitant to explore it, then you have come to the right place. Hi, my name is Imran Afzal, and I've been working in IT field for over 2 decades now. I have been teaching for the last 10 years, and I have taught some of the best-selling and highest-rated courses to over 500,000 students worldwide. In this course, I will lead you through a comprehensive step-by-step journey of Java coding. We will start from the basics and move to more advanced concepts using straightforward and accessible approaches. With over 30 hours of instructional content, including tutorials, coding exercises, quizzes, you will have ample opportunities to practice and reinforce your training. Whether you are a complete beginner or already have some programming knowledge, this course is tailored to accommodate learners of all levels. And if you already possess a programming experience, imagine how quickly you will be able to breeze through the course and enhance your skills. Also, I have partnered with another instructor in this course named Jshell, who possesses extensive expertise in Java coding. All right, one last thing, and most important thing. If you are someone who wants a job in Java or wants to level up their career, then this is the perfect course for you. You have 30 days to cancel and request a full refund, so you got nothing to lose. So let's go ahead and enroll.
What is computer language? Before we explore the topic of Java programming, first it is very important that we understand what is computer language. Computer does not know any human language, so they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language, that 0 and 1 language, it's called binary. Computers store all characters as numbers on hard disk because computer don't know what is hello or how are you is. The computer converts that into these number zeros and ones, and that's how it stores that into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power or if your battery runs out of your laptop, your computer will shut down, right? So computer to transmits the data, to save that data, it actually uses 0 and 1, and that 0 and 1 concept came from the electricity. 0 means off, and 1 means on. So this I or 1 that you probably see on your switch. If you go to your switch right now, or if you have an older switch, probably newer switch don't have those 0 and 1 anymore. But if you find one in your house, you're gonna look at it closely, and you're gonna see 1 on top or at the bottom, depends which country you are in. So the 1 means that turn on. 0 means to turn it off. Similarly, the computer sends or saves the data on the computer or transfer the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. Each letter that we have has a number or a binary number associated with it. So like A has 100000001, B has 1000010, and so on. So now let's say if you type it in hello on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory that, hey, this hello means these digits, so process it. So the first thing it will do is we'll take the first character, which is H. And by looking at the chart, you will see the H translates to 1001000, meaning on, on, off. Same thing, E translate to 1000101. L, L, and O 1001111. So that's like a cheat sheet the computer has, and computer knows that when the letter H comes in or E comes in, I'm gonna have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off, and that's how it actually move the data from one computer to another or from your keyboard to the hard disk. I hope now you have a better understanding of computer language. You might be wondering why programming languages like Java, Python, Ruby, and so on are necessary if computer already has its native binary language. That's an excellent question. Now allow me to clarify one thing. It is indeed possible to write programming code directly in binary language, but it would be very tedious and time consuming. The reason we use these programming languages is that they enable us to write code in a manner that is more accessible for humans to understand, debug, and of course troubleshoot in case there is an issue. So ultimately, regardless of the programming language that you use, the code you write is executed by the computer hardware in the form of binary instructions. In addition, binary language is commonly known as low-level language, while other programming languages are referred to as high-level languages. It is important to note that the term low or high level do not imply any kind of ranking. Binary language is considered low level because it directly interacts with the computer hardware, while the other programming languages operate on top of it. When a higher level language communicates with a computer, there is an intermediary component that translates it into machine or binary language. This essential bridge that you see, that middle piece between them, is known as a compiler software. So, I hope this clarifies the concept of a computer's native language and why we utilize other programming languages. In the next video, we will cover some of the commonly used programming languages available. Types of programming languages. In this lecture, we will provide an explanation of the various types of programming languages. As discussed previously, programming languages are commonly categorized into two types: low-level and high-level. Low-level languages are designed to be understood directly by the machine and executed by the CPU. On the other hand, high-level languages are more user-friendly and resemble human language. By utilizing these high-level languages, programmers can write code more efficiently and effectively, reducing errors and saving time. Also, high-level languages are designed to be closer to natural language and allow programmers to express their intentions. So, coming back to the topic, there are various types of programming languages, each designed with different purposes and applications in mind. Here are some of the main categories. First one is procedural programming languages. In procedure programming languages, a program is divided into a series of procedures or functions that are executed in a sequential manner. These procedures contain a series of instructions that are performed step by step to solve a problem or complete a task. Examples include C, Pascal, and Fortran. The next one is object-oriented programming language, which is the primary focus of our course. The OOP, which is in short of object-oriented programming, organizes the code around objects. Now, what is an object? An object can be anything that you see around you. For example, a table, a chair, a phone, a glass, or even a cat, a game player, or even a button. It describes what a thing is and what it can do. Examples of these languages are like Java, C++, Python, C Sharp, Ruby, PHP, and so on. I will cover the object-oriented programming in more detail in the next video. The next one is functional programming. Functional languages see computation as performing calculations just like a math. They focus on making things unchangeable and avoiding actions that can cause unexpected consequences. Examples include Haskell, Lisp, and Erlang. Then there are scripting languages. These languages are designed for scripting and automation tasks. They are often understood and processed as they are read, and they can handle different types of data without strict rules. Examples include Bash, shell scripting, or C shell, JavaScript, Perl, Ruby, and so on. Then going to the next one, which is the markup language. These languages are used to define the structure, presentation, and behavior of documents. They are not traditional programming languages, but are essential for web development. And examples of markup languages include HTML, XML, and CSS. Then we have query language. These languages are designed specifically for querying and manipulating database. SQL, which stands for Structured Query Language, is the most well-known example of such language. And there are some other ones, for example, domain-specific language, concurrent programming language, and logic programming languages. Object-oriented programming. In this lecture, we will discuss object-oriented programming in more detail, and I will try my best to explain it in a very simple way. In object-oriented programming, we mainly deal with objects. An object can be anything like a person, place, or a thing. It has a specific structure and can do certain things. If you think about things that are not considered objects, we're talking about entities that don't have a clear shape or form and don't do anything specific. Examples of such non-object entities are emotions like happiness or abstract ideas like freedom. These things are not classified as objects because they don't have a physical structure and don't show actions in the same way as concrete objects do. Let me explain you the object-oriented programming through an example. Going back to the basics of programming, which is the procedural or sequential programming. In this type of programming, you write a code in a sequence, right? For example, we want to write a code which will have a set of instructions, and for that, we will use an example of driving a car and pick up groceries. So the code will look something like this. Unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, then of course drive to the nearest grocery store, buy a loaf of bread and a dozen eggs, and of course come back to your car and unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, and then drive back home. Now, if you notice that actions 1, 2, and 3, 4 are similar to actions 7, 8, 9, and 10. Imagine if you have to stop off at another store as well, then you are repeating these steps again and again, which is of course not efficient. So what we do is we define an object and its functions in something we call a class. So it will be something like class of an object, and the object will be the car. So, for example, we define car as an object and its class that will have functions of unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt. Now, if we write our code again, it will become a lot easier to manage. Look at that. Object is the car, then, of course, drive to the nearest grocery store, buy a loaf of bread and dozen eggs, then again, define object, which is the car, and drive back home. You see, now our code suddenly became from 11 lines to 5 lines. See, that's why the object-oriented programming became so popular. So object-oriented programming is a way of writing computer programs that focuses on organizing and managing data by grouping it together with the code that operates on the data. Or in simple word, it treats everything in a program as objects that have their own unique characteristics and behaviors. It helps programmers to create modular and reusable code by breaking down the program into smaller, self-contained objects that interact with each other. Just like we created the car as an object which has its own smaller self-contained program. This approach allows for easier understanding, maintenance, and of course, expansion of your program. So I hope this example that I have given you is enough and clear enough to make you understand what is an object and why we use object oriented programming when we write a program. So far, we have learned all the different type of programming languages. Now let's spend some time to understand which language is best suited for which application. I want to start off with C++. C++ is a powerful and versatile programming language that was developed as an extension of C programming language. It was created in the late 1970s with the intention of adding object-oriented programming features. All right, so let's take a few examples of C++ applications that are available today. The very first one is the operating systems. Yes, most of the operating systems that you use or build on your computers nowadays are built using C++, and examples are like Windows, Mac OS, and Linux. Then there are many games that are built using C++, such as Grand Auto Theft, The Witcher, World of Warcraft, Doom, League of Legends. Moving on to graphics and multimedia applications, such as Adobe, Autodesk, Blender, and DirectX. Then there are financial systems that are built using C++. Some of them are like trading systems, risk management software. Then there are database management systems that uses C++ language. And those database management system examples are like MySQL, PostgreSQL, and MongoDB. And then the embedded systems are also built using C++, and those systems are automotive systems, medical devices, and smart home automation. All right, that's about C++. Now let's talk about our main focus of the course, Java. Java is programming language that can run on different computer systems without needing changes. Examples of Java applications are big business software such as customer relation management system, human resources management system, supply chain, and so on. Also, Java is heavily used on websites such as banking system, e-commerce platform, content management system. Mobile apps are also built using Java, primarily in Android. Mobile apps examples are WhatsApp, Facebook, Instagram, Spotify, Airbnb, Uber, and the list keep goes on. Then other applications, such as scientific applications, are used or are built using Java. And examples are image analysis, processing, computational chemistry, bioinformatics, astronomy, and so on. Then, not to forget the games. There are many games that are built using Java, such as Minecraft, Runescape, and many other puzzle and game or card games that are used using Java language. All right. The next one is Python, which is easy to learn and understand. Example of Python applications are web development. Now you probably notice web development is something that can be done using many different languages. It depends the purpose of your website. You could use different languages to build it. The examples of Python web applications are Instagram, Pinterest, Dropbox, and Reddit. Data analysis and visualization is another form of application that is built using Python, and examples are Jupyter Notebook, Pandas Data Frame, Seaborn. Then moving on, machine learning and artificial intelligence applications are built using Python, and some of them are image classification, virtual assistant, healthcare applications. Moving on to the list of applications using Python is scientific computing. Then we have automation and scripting application. We also have desktop GUI application that can be built using Python, and examples of those GUI applications are like calculator, text editor, music player, spreadsheets, and so on. All right, then not to forget games. Game development can be done using Python as well. And the example of games are Snake Game, Tic-Tac-Toe, Hangman, Sudoku, and many other applications. Then moving on to C Sharp. While C Sharp is a programming language made by Microsoft, it is used to create different type of applications such as Windows desktop application, like text editor, media player, file compression. Then there are web applications such as e-commerce website, real estate listing platforms, booking and reservation system, online learning management system. Other applications are like mobile application, which are fitness tracking, expense tracking, news feed, task manager. Then games, 2D platformer, racing games, adventure simulation games can be built using C Sharp. Then moving on to Ruby. All right, Ruby is a dynamic object-oriented programming language known for its simplicity and readability. Examples of Ruby applications are web applications mainly used for social networking websites, online marketplaces, and blogging platform. Then we use command line tools or we build command line tools using Ruby. And those tools are like backup utility, password generator, network monitoring tools. Then there are automation scripts that are built using Ruby, mainly used within the operating system for tasks such as scheduler, database maintenance, deployment. Then other applications are like testing and quality insurance. And the last one, and not to forget the most famous one that is coming nowadays, really famous, are the chatbots. Those chatbots used for customer support, travel assistance, job search, and language learning. So now I'm sure you understand why we have so many different programming languages and which one is best suited for your needs. In this lecture, our focus will be on understanding the distinction between a computer programmer and a software developer. We will explore the unique roles and responsibilities associated with each profession. A computer programmer is defined as a person who has expertise in programming languages and uses such languages to create code for applications. Additionally, they might help write tests for these applications. A software development, on the other hand, is more involved in the application design. They spend a lot of effort ensuring the usability and behavior of the application, including how users interact with it, the application flow, and its accessibility. Software developers frequently collaborate with clients to fully grasp their needs and choose the best possible solution to include into the application. The primary focus of a software developer is to prioritize understanding the customer needs and finding effective solution to address those needs. They place a strong emphasis on creating user-friendly application that effectively solve customers' problem. Let's consider a scenario where ABC Bank is well-established financial institution, recognizes the increasing demand for mobile banking services among its customer base. To meet this demand and provide customers with convenient and secure access to their account, ABC Bank decides to develop a mobile banking application. The project begins with a team of software developers in this scenario. They work closely with ABC Bank's product managers, business analysts, and user experience designers. They conduct a user research, gather insights, and analyze customer needs and expectations for that mobile banking application. Based on the information, the software developers create wireframes and design mockups of the application user interface. They focus on designing an intuitive and visually appealing interface, ensuring easy navigation and smooth user interaction. They incorporate user-friendly features such as Touch ID or facial recognition for quick and secure authentication, as well as options for personalized notification and account alerts. Throughout the development process, software developers maintain a constant feedback loop with stakeholders and customers, conducting usability, testing sessions, and gathering feedback to iterate and improve the application's design and functionality. They prioritize understanding customer needs, designing a user friendly interface, and ensuring an optimal user experience. While the computer programmers in this scenario collaborate with the bank's IT department, software architects, and software developers, they are proficient in programming languages. Their primary responsibility is to implement the technical requirements and architecture defined by the team. The programmers start by creating an authentication module, enabling users to securely log into their accounts. They implement encryption protocols and establish secure connections with the bank servers to safeguard sensitive information. They then focus on developing the core functionalities of the mobile banking application, such as displaying account balances, transaction histories, and e-statements, as well as integrating secure payment gateways for fund transfers. They ensure that the application adheres to industry standards and best practices to mitigate security risk. The computer programmers also work closely with quality assurance team to write comprehensive test cases and conduct rigorous testing, including functional and security testings. They prioritize the technical implementation of the application's features, ensuring reliability and accuracy. In this lecture, we will start with our primary focus of Java. Previously, we covered high-level and low-level programming languages and the purpose of each language and its applications. So now, let's start with the definition. As per Wikipedia, Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. It is a general-purpose programming language intended to let programmers write once, run anywhere, meaning that the compiled Java code can run on all platforms that support Java without the need to recompile. Now, that was the exact definition out of Wikipedia. So now let's put it in a very simple words. Java is a programming language that allows you to create software and applications for various devices like computers, smartphones, and a lot more. Whenever you go find the purpose of Java, one advantage of Java will be repeated and highlighted in all of its purposes that our Java is a platform independent language. Because of this advantage, Java is also called a two-stage system. This means that Java source code is converted to machine code in two steps. In the first step, the code is translated into a special format called bytecode by a program compiler. And in the second step, the bytecode translated into machine code by a program called interpreter. This special process makes Java more secure because the code runs in a control environment, preventing any harmful actions. So, thanks to this Java feature, which made Java more secure and gave it the ability to run on different devices without any changes. Java was also designed to be easy to learn and use and to be efficient and reliable. These characteristics have contributed to the popularity of Java and have made it a widely used language for building a variety of applications. Now, let's talk a little about the history of Java, which is quite interesting. So, Java was originally developed by James Gosselin, Mike Sheridan, and Patrick Norton at Sun Microsystems in the early 1990s. The project was initially referred to as Oak, after an oak tree that stood outside James Gosselin's office. However, the name Oak faced some legal challenges when Sun Microsystems realized that another company already had the rights to that name. Now, as a result, they had to look for an alternative name. Eventually, in 1995, the name Java was chosen as a replacement for Oak. Now, the name Java is said to be inspired by the coffee beans from the Java island in Indonesia, reflecting the team's passion for coffee. That's why if you see the logo of Java, it's a coffee cup because it is connected to coffee beans from Java Island, Indonesia. In the logo, the rising steam adds a fun and lively element, representing the language energetic and dynamic nature. So, Java was seen as a unique and catchy name that could be trademarked without an issues. So, using Java, James Gosselin, Mike Sheridan, and Patrick Norton initially wanted to make a system for interactive television, but later they changed it to work on the World Wide Web. So, Java was designed for one purpose but ended up being used for something else and became so popular on the internet. Java became available to the public in 1995 and became very popular because of its special features called Write Once and Run Anywhere. Then in 2010, Oracle Corporation bought Sun Microsystem, and that's when they got the Java programming language. Nowadays, Java is super famous and liked by many programmers all over the world. All right, I hope you learned something useful in this lecture as well, and I will see you in the next one. In this lecture, we are going to talk about how to succeed as a Java developer. One of the primary reasons to consider learning Java is its extensive adoption by top companies. With a history spanning over 20 years, Java has established itself as stable and reliable programming language favored by prominent IT corporations. Now, according to StackShare, around 10,000 companies include Java in their tech stack, including industry leaders such as Google, Netflix, Facebook, Airbnb, Uber, and many more. While these companies also utilize other emerging technologies, but Java remains a key component in their software development ecosystem. It is no surprise that Highly trained and skilled Java developers are in high demand with attractive salaries, of course. According to Indeed.com, the average base pay for entry level Java developers is around $70,000 per year, with potential for significant growth as experience and skills increase. Now, salaries can reach up to $150 to $200,000 per year for experienced Java developers. According to Stack Overflow, that conducted a survey in 2022, Java consistently ranks among the most popular programming languages. All right, so now let's get back onto the topic, how to succeed as a Java developer. It is important to stay up to date with the latest advancement frameworks and best practices through continuous learning. Explore online resources. There are many online resources where you could get your training, documentation, tutorials, and participate in forums to expand your knowledge. Apply your knowledge by working on real world projects. Then engage with the Java community. Join developers forum and participate in open source project. There are many that you will find online. So collaborating with other developers exposes you to diverse perspectives, fosters learnings, and helps you stay connected with the latest trends and opportunities. Okay, then familiarize yourself with powerful Java development tools like Eclipse, NetBeans, and IntelliJ IDEA. Now, these IDE offers a wide range of features that streamline development, debugging, and code maintenance, ultimately boosting your productivity. Then, not to forget, write clean, efficient, and well structured code. Follow coding conventions, use proper naming conventions, and leverage design patterns to ensure your code is maintainable and scalable. All right. Then another advice is invest time in understanding the core concept of Java, including object oriented programming, inheritance, polymorphism, and exception handling. A strong foundation will empower you to tackle complex projects with confidence. Then actively seek feedbacks from peers, mentors, and experienced developers to enhance your skills. Embrace constructive criticism, learn from your mistakes, and strive for continuous improvement in your coding practices. All right, by following these guidelines and continually refining your skills, you can position yourself for success as a Java developer, opening up a world of opportunities for you in a language known for its versatility, industry support, and robustness. In this lecture, we will talk about the Java software tools such as JDK, JRE, JVM, and IDE. To write and run a Java program, we first set up Java environment. Now, what is an environment? In general sense, an environment refers to the surrounding or conditions in which something exists or operates. In the context of setting up a Java environment, it specifically refers to the configuration and preparation necessary for running Java programs either on your local machine or on a server. Setting up a Java environment involves installing the necessary software and tools that are required to develop and execute Java programs. So, the first thing that we install is JDK, which stands for Java Development Kit. It contains all the tools required to run Java programs. JDK includes a Java compiler, which is used to translate Java code into a form that can run on a computer, as well as a set of libraries and tools that are needed to develop Java applications. Now, JDK includes a component called JRE, which stands for Java Runtime Environment. JRE includes libraries as well as Java Virtual Machine, in short, JVM, which is the most important Java component. JRE is a software package that provides a runtime environment in which applications can be executed. So JVM, which is a part of JRE, is a program that interprets Java bytecode and executes it on a computer, as well as a set of libraries and tools that are needed to run Java applications. Then we must have a code editor. We will use an IDE IntelliJ in our course, which stands for Integrated Development Environment. You can use other code editors such as Eclipse or Visual Studio Code, but we'll stick around with IDE throughout this course. An IDE typically consists of a source code editor, build automation tools, and a debugger. Some IDEs also include a compiler or interpreter. So, to put it in simple words, JDK, JRE, and JVM are stored one inside the other, level by level. Now we discuss the how Java code is actually run. Our Java code executes in two steps. The first step is compilation and the second step is execution. Let's talk about the first step. The code we write in Java is called source code. The source code is stored in a file with the extension .java. All of this source code is sent to the compiler, which is included in the JDK, and the compiler converts it into bytecode with the extension .class. This bytecode can be run on any other system that has JRE installed. If you write Java code in Linux, Windows, or Mac, we simply convert it to bytecode, which can then run on any systems. Therefore, Java is called a portable or multi-platform language. The first step, compilation, is covered now. Now come to the second step, which is the execution. In this step, the JVM takes this bytecode and converts it into native code. So the native code is the code that a machine can understand. Now tell me, what is the name of the native code that we talked about earlier? What is it called? It's called binary. Yes, if you guessed it right, excellent job. Once your bytecode has been converted into that binary or native code, your machine will be able to understand it regardless of which operating system it is running on. So, in summary, we write Java code and save it in the .java extension, and it's gonna be known as source code. Then JDK has a compiler that converts this source code into bytecode with the .class extension. This process is known as compilation. Then this bytecode is given to the JVM that is inside the JRE. This bytecode is converted into the native code by the JVM. This is called execution. So, I am sure by now you have a better understanding of each Java components and how they work together. I will see you in the next lecture.
Lab setup. In this lecture, we will go through our lab design, the lab that you will be practicing Java throughout this course. So, the very first thing you need to do is to download and install JDK. We will be covering the installation of JDK on Windows and on Linux. So, first identify what kind of computer you have. Also make sure you have the available resources, like memory, CPU, disk space. When installing JDK on Windows, it's important to remember that most modern computers use the 64-bit edition of Windows. Therefore, you should install the 64-bit version of JDK to ensure compatibility and take advantage of the system's capabilities. So, for installing JDK on Windows, your computer should meet the minimum system requirements. which typically include at least 2 gigabytes of RAM, a processor with a speed of 1 gigahertz or higher, and around 200 megabytes to 500 megabytes of free disk space for the installation. These specifications ensure that JDK functions properly on your Windows system. Here, good news is when you install the latest version of JDK on Windows, there's no need to separately install the JRE. The JDK installation already includes both the JDK and the JRE, so everything you need is bundled together in one installation. When JDK is installed successfully, it also installs a command line tool called Jshell. In the beginning lectures, we will use Jshell to quickly explore Java features without writing full programs. After learning Java basics, you will install IntelliJ IDE. That is an integrated development environment, in short IDE. This IDE allows us to create fully documented programs and projects efficiently. Now we will talk about JDK installation on Linux. To begin with JDK installation on Linux, you will first need to set up a Linux operating system on VirtualBox. Then you can log in into Linux operating system and proceed with the JDK installation. After that, you will write some installation commands on terminal that will install JDK on Linux operating system. If we talk about the system requirements for JDK installation on Linux, they are the same as for Windows, and also same process for Jshell. But for installation of IntelliJ IDE, we will use some installation command for IntelliJ IDE in Linux terminal. Once the setup is completed on both Windows and Linux operating systems, both systems have Java environments. Now, when you will create a Java source code file with the extension .java on a Windows or Linux operating system, the Java compiler will translate the .java file into bytecode, which will now be saved with a class extension. Then this class file, which has bytecode inside it, will translate it into machine code by the interpreter. This interpreter is basically called JVM. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Install JDK Java Development Kit for Windows. In this lecture, we will learn about how to install Java Development Kit for Windows 10 and 11. If you're using a Mac, Linux, or have already installed JDK on Windows, then skip this lecture. If you are running Windows 10, please keep in mind that most modern computers run the 64-bit edition of Windows 10, and Windows 11 is already in the 64-bit edition. If you're using a 32-bit version of Windows 10, that's where things may become tricky. You can do this by downloading an older version of JDK that is compatible with your Windows system. As a result, the JDK installation process is the same, whether you're using Windows 10 or Windows 11 64-bit version. Now let's begin our JDK installation on Windows. Write this URL, java.sun.com, in your favorite browser. Now click on the Java C1705 version. If you don't know why we take this version, then see our previous lecture, Introduction to Java version 17 LTS. You should now see 3 tabs, Linux, Mac OS, and Windows. So select the Windows tab and click on the x64 installer download link. This will download the installer file to your computer. Now the download begins. It takes some time as per your internet speed. Once the download is complete, open the installer file and follow the prompts to install the JDK. Make sure to remember the installation location as you will need it later. Here is my installation location. After the installation is complete, you will need to set the Java home environment variable to point to the JDK installation folder. To do this, follow these steps. Go to the Start menu and search for Environment Variables. Click on Edit the System Environment Variables button. Click on the Environment Variables button. Under the System Variables section, scroll down and find the Path variable. Click on the Edit button. Click on the New button and add the path to the JDK installation folder. You see here my JDK installation path. Now paste this path here and click OK to save the changes. To test the JDK installation, open a command prompt and enter the following command, Java-version. This should display the version of the JDK that you have installed. If you see an error message, make sure that the JDK installation location is correctly set in the path environment variable. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Install JDK for Linux. In this lecture, we will learn about how to install JDK for Linux. We're going to install JDK version 17 LTS on CentOS Linux. Check out the relevant videos for your operating system if you use Windows. So let's start. I am setting up a virtual machine using VirtualBox on Windows. Installing CentOS Linux as the operating system on the virtual machine, and connecting PuTTY software with CentOS Linux. So PuTTY is available for Windows, MacOS, and Linux operating systems, and it can be used to connect to any computer that has a supported network service running, such as an SSH server. You may use it by installing CentOS Linux or any other Linux flavor as a dual boot system or in a virtual machine. Now come to the installation. First, we run our machine as the root user and then given root password. Now we use the command Java-version to see if OpenJDK is installed or not. This statement tells us that Java is not installed on this system. To download JDK 17 LTS from the CentOS terminal, you can follow these steps. First, you update the package manager's database. For this, run the sudo yum update command to update the package manager's database. It takes some time according to the speed of your internet connection. Now download Oracle Java JDK 17 LTS. For this, run the wget with this download link command in the terminal. This will download JDK 17 LTS and all the required dependencies. It takes some time. After download completed, now install Oracle Java JDK 17 using the RPM command and press enter. It takes some time. Now, to verify that JDK 17 LTS has been installed correctly, run the Java-version command. This should display the version of the JDK that is currently being used. The output should look something like this. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Jshell Introduction. In this lecture, we will talk about what Jshell is and why we use it, and we will also see how to use it on Windows and Linux, and run some important commands on it. Let's start with what is Jshell. Jshell is a command line tool in Java that allows you to execute Java code snippets and commands in an interactive manner. It is included in the Java Development Kit starting from version 9. The next is why we use Jshell, because when you enter code with the Jshell prompt, the tool will immediately execute the code and print the results to the console. For example, if you enter a simple math expression, such as 2 plus 2, with the Jshell prompt, the tool will execute the expression and print the result 4. Jshell can be used in conjunction with other tools, such as IDEs, text editors, and build systems. Jshell provides a number of commands that you can use to control the execution of your code, such as /list to list the code snippets you have entered or /exit to exit the Jshell tool. With all of Jshell's features, it also has some limitations. Thus, after some practice writing Java code on it, we will move on to the IDE. So, the limitation of Jshell is that it does not replace the need for an IDE. It's just a handy tool to quickly get started with Java. It is not intended for use as a full-featured development environment and may not be suitable for larger or more complex projects. Jshell only includes support for the core Java language features and standard library. If you want to use third-party libraries, you will need to use a full Java program. Now come to the installation of Jshell. It is automatically installed when you install the JDK. In our case, we installed JDK version 17 LTS. So let's start with Windows. Now open the Windows terminal by typing CMD in the Windows Start search bar or by pressing the Windows plus R keys, typing CMD in the Run dialog and then pressing Enter. But in CentOS Linux, you can do this by pressing Ctrl plus Alt plus T, or by clicking on the terminal icon in the taskbar. Now that the terminal is open, we type Jshell here. Now we see Jshell here, and that is the version of Java that we use. If we want to see the introduction of Jshell, just type the command /help intro and press Enter. Here is its introduction. If we want to see Jshell commands and what they are used for, then just type /help. Here are these commands. Just a couple of the most popular commands will be covered, not all of them. As you can see, there are commands to save and open files. Reset Jshell L to the time of its installation. Review your typing history and other things. Let's look at the list command, which is the top command there. The /list command is a Jshell command that allows you to view the code snippets and commands you have entered in the current Jshell session. To use the /list command, you can enter /list at the Jshell prompt, followed by a range of snippet numbers to list. For example, if we type 2 plus 2 and then hit Enter, now it shows the result of 4. Now type /list command and press Enter. It shows the code that we wrote before. Now use the /exit command to quit from Jshell. For this, just type /exit and press Enter. Now it says goodbye and we're done with it. Now let's try Jshell on CentOS Linux. If you are using dual boot system CentOS, then you can open terminal by pressing Ctrl plus Alt plus T, or by clicking on the terminal icon. As I previously mentioned, I am using PuTTY to connect with my CentOS machine. For this, first I log into my Linux machine using PuTTY. Now I type Jshell. Now we see Jshell here, and that is the version of Java that we use. If we want to see the introduction of Jshell, just type the command /help intro and press Enter. Here is its introduction. Now it will work the same as Windows, as we've seen before. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Java First Program using Notepad and Command Prompt. In this lecture, we will talk about how to write Java First Program using Notepad and Command Prompt. This is the only lecture where we will write Java code on Notepad and run it on the Windows command prompt. Otherwise, we will write Java code using Jshell and then go to the IDE. So, the purpose of this lecture is to show a clear understanding of how Java runs, why Java is referred to as a two-stage system language, how Java converts source code to bytecode in the form of a class file, and how the JVM interpreter executes it. To begin the demonstration, open Notepad. Here we write a Java program that prints "Hello World" on the screen. Now we write it after the code is finished. Then we save it with the name "Hello World," which is the same as the class name with the .java extension. Because it's a Java rule and I save it in a directory that I've already created called Java-code, as you can see. Remember that the main purpose of this lecture is to learn about how Java is basically run. So I will explain this code in the coming lectures. Now open Windows command prompt and give it the path where my Java source code file is saved. This is where I keep my Java source code. You can also see its type here. Now go to the command prompt and type javac, which stands for Java compiler, followed by the name of a Java file with a .java extension, and then press enter. The Java compiler now converts the source code into bytecode and creates the file with the .class extension. Here you can see this file and its type. Now we'll open it and see what's inside. We can see that it's a bytecode that is not in a human-readable form. Now come to the command prompt again. Now call the JVM interpreter to convert this bytecode into machine language. For this, type Java and then class name that is Hello World. And press enters. Now you can see the output. I hope you learned something useful in this lecture as well. And I'll see you in the next one. Our first program, Hello World, using Jshell. In this lecture, we will talk about how to write a Java program called Hello World using Jshell. Hello World is a simple program that is often used as a starting point when learning a new programming language. This program typically just displays the words Hello World on the screen. It's a basic program that allows you to test the syntax of the language and get a sense of accomplishment after completing it. Even experienced programmers can feel a sense of accomplishment after writing their first Hello World program in a new language. Completing this simple task is often seen as the first step towards being able to write more complex programs. Before we start writing Java code, we must remember the rules of how to develop a Java program. Here are some basic rules to follow when writing Java code. Java is case sensitive, so be careful when using keywords, variables, and method names. Every statement in Java must end with a semicolon. Java uses curly braces to group blocks of code. Java is an object-oriented programming language, so all code is organized into classes. Each class must have a unique name and should be saved in a separate file with the same name as the class, followed by the Java extension. Every Java program must have a main method, which is the entry point of the program. The main method has the following signature: public static void main string RGS. Java uses camel case for naming conventions. This means that the first letter of each word in a multi-word identifier is capitalized except for the first word, which is all lowercase. For example, Hello World is a valid identifier in Java. Java uses the double slash symbol to start a single line comment, and the slash asterisk and asterisk slash symbols to start and end a multi-line comment. Comment plays very important role in Java or any other programming language. Comments help to document the code, making it easier for others or even yourself to understand what the code does. This can be especially useful if the code is being worked on by a team of developers, or if it is being maintained over a long period of time. Comments can serve as a reminder of the purpose of a particular piece of code, which can be helpful if you need to make changes to the code later on. Comments can help to improve the readability of the code, making it easier to follow the logic of the program. These are the general rules that must be followed when writing complete and comprehensive Java code. Now come to Jshell. So when we write code in Jshell, it only allows us to write and run Java code snippets and expressions, which are small pieces of code. For example, in the previous lecture, we wrote a complete Java program that prints hello world on the screen. Here you can see that. And this code is written according to Java rules. Now we see this statement system.out.println, and it used to print content on the screen. As a result, we can use only this piece of code only, rather than writing the entire Java class in Jshell. That's the reason we write Java code snippets in Jshell. Now for demonstration, open the command prompt and then type Jshell. Now we are in Jshell. Now we write the statement system.out.println. After that, use parentheses in the double quotation, and inside it we write hello world. Using this statement, we are telling Java to print hello world on the screen. Now press the enter key. Here is the output that says hello world. When we use single quotation marks around hello world, instead of double quotation marks, we get the error, which is unclosed character literal, because we define a string with a single quotation mark here. That is not the Java rule. The single quotation used for character. We discuss character and string comparison in the coming lectures. This error is also displayed when we miss any quotation like this, as we can see. Now remove the last bracket and press enter. What does it mean? As you can see, the gesture prompt has changed, and it is now 3 dots followed by a greater than symbol. It is telling us that Jshell is ready for another line of code to be typed in, and you can keep adding new lines of code by pressing enter in between without anything actually running, until you complete the set of brackets. If we want to exit without writing any lines, we can do so by pressing Ctrl+C. Now we write the bracket and press enter, and that's the output. As you can see, we don't write a semicolon at the end, because in Jshell a semicolon is optional. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Variables in Java. In this lecture, we will talk about variables in Java. Before we get into variables, let's first define keywords. In Java, a keyword is a word that has a specific meaning in the programming language. These words are reserved, meaning they cannot be used as names for variables, methods, or other identifiers in your code. Keywords are also case sensitive, so int is a different keyword than with start capital I int or all in capital int. There are several types of keywords in Java, including primitive data types. These include keywords like int, double, and char, which are used to represent basic types of data in the language. Control statements. These include keywords like if, else, and while, which are used to control the flow of a program's execution. Modifiers. These include keywords like private, public, and final, which are used to modify the behavior or accessibility of a class, method, or variable. Other keywords. There are several other keywords in Java, such as this, super, and null, which serve various purposes in the language. We will discuss all this step by step in the coming lectures. Now come to the variable. What are variables? All variables are means for storing data in our computers. Variables that we declare in a program may be accessed by the name. We give them, and the computer handles the difficult task of determining where they are stored in the RAM. Now, as their name implies, variables may be modified. Its contents may change. In other words, we must thus advise the computer of the kind of data we want to keep in the variable before giving it a name. We may create a wide range of various forms of data for our variables, some of which you saw in the keyword list earlier. These are often referred to as data types. As you may have predicted, Java uses some data types, known as basic data types, as keywords. In other words, a variable is a named location in memory, where a programmer can store a value of a specific data type. Variables are used to store information that can be changed or used later in a program. For example, to declare an integer variable named age, you would write int age semicolon. Once a variable is declared, you can assign a value to it using the assignment operator. For example, to assign the value 25 to the variable age, you would write age equals sign, then give value 25, then semicolon. Java has several primitive data types, including integers as int, floating point numbers, float and double, characters as char, and booleans. The data type of a variable determines the kind of information it can store and the operations that can be performed on it. It's important to choose appropriate data types for your variables as this can affect the performance and accuracy of your program. For example, using an integer data type to represent a decimal value may result in loss of precision. In addition to primitive data types, Java also supports object data types, which are variables that reference objects. Objects are complex data structures that contain both data and behavior methods. We'll cover objects in more detail in later lectures. Let's open Jshell to see how to define our first variable. To define an integer variable named age with the value 25, using Jshell, you can use the statement int age equals 25, then semicolon, and press enter. Now this will create a variable of type int with the name age and assign the value 25 to it. It's important to note that in Java, every statement must end with a semicolon. The semicolon indicates the end of a statement and is necessary for the compiler to correctly parse your code. Once you have defined a variable, you can use it in your Jshell commands by referencing its name. For example, you can print the value of the variable age like this: system.out.print parenthesis, then use variable age inside it, followed by a semicolon to finish the sentence. This will print the value of the age variable to the console. You can also change the value of a variable by assigning a new value to it using the assignment operator. For example, to change the value of the age variable to 30, you can use the statement age equals 30, then semicolon. This will assign the value 30 to the age variable, replacing its previous value. Here we use a word statement. Now we discuss it. In Java, a statement is a piece of code that performs a specific action or task. A statement can be a simple statement that performs a single action, or it can be a compound statement that contains multiple statements and control structures. There are several types of statements in Java, including expression statements, declaration statements, and control statements. First, we discuss expression statements. So, expression statements are statements that contain an expression, which is a combination of variables, operators, and method calls that evaluates to a value. An expression statement is usually followed by a semicolon. Int age equals 25, then semicolon is an example of an expression statement. Then the declaration statements. These are statements that declare a new variable, field, or method. A declaration statement usually specifies the data type and name of the entity being declared. There are also two concepts used in variables: declaration and definition of variable. Declare means to create a variable with a data type but not assign it a value, like int age and semicolon. Here we not assign any value to it. This is also called a declaration statement, and definition refers to when we assign it a value. For example, int age equals value 25, then semicolon, then control statements. These are statements that control the flow of execution in a program. such as if statements, while loops, and for loops. All of this will be covered in the upcoming lectures. Then block statements. These are statements that are enclosed in curly braces and can contain multiple statements and declarations. A block statement is often used to group related statements together or to define the body of a control statement or method. Now we solve a practice question. That is, use the system.out.print method to alter the my age variable's value from 30 to 65 and print the new value. Now come to Jshell. First we declare an integer variable named my age and assign it the value 30. Then it uses the assignment operator to change the value of my age variable to 65. Finally, it uses the system.out.print method to print the value of age to the console. Now this code is executed, it will output the output that is 65. It's important to note that the value of a variable can be changed at any time during the execution of a program by assigning a new value to it using the assignment operator. This is a useful feature of variables as it allows you to store and manipulate data in your programs. Let's use the Jshell command /list to list all of the statements we've run and given values to. For this, just type /list and press enter. This will show lists of all the Java statements you've executed in Jshell. Now we clear the shell screen using Ctrl+L. Now we see another example using the arithmetic symbol, plus and then storing it in a variable. Now let's define this statement. Here my number is a variable of type int that is being assigned the value of the result of the expression 5 plus 10. The equals symbol is the assignment operator, which means that the value of the expression on the right side of the operator is being assigned to the variable on the left side. In this case, the expression 5 plus 10 is evaluated to produce the value 15, which is then assigned to my number. After this line of code is executed, my number will have the value 15. Now we print the value of my number using system.out.print method. Here is output. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Variables and expressions. In this lecture, we will talk about variables and expressions. In the previous lecture, we discussed variables, how we store data in them, and how we use them. Now we will work on some complex mathematical expressions and store them in variables. Here we can see a literal value in the expression, and its result is stored in a literal variable. That is, int literal variable equals 20 divided by 2 plus 10 plus 2. The expression 20 divided by 2 plus 10 plus 2 in Java is a simple arithmetic expression that combines addition and division. The slash operator performs division and the plus operator performs addition. In Java, the division operator returns a floating point result even if both operands are integers. The parentheses in the expression 20 divided by 2 and 10 plus 2 are used to specify the order in which the operations should be performed. In this case, the operations within the parentheses are evaluated first, followed by the operations outside the parentheses. Therefore, the expression 20 divided by 2 plus 10 plus 2 will be evaluated as 10 plus 12, which is equal to 22. The result of the expression is then assigned to the literal variable, which is an int variable. The value of literal variable will be 22. Now run the Jshell and create a variable called literal variable with an int data type, and given this expression as a value to this variable. Now press enter, and here you can see the result. Now in the next example, we create a variable named second variable. Give it a value of 50 and add this variable to the previously created variable, named literal variable, and the result is stored in the sum variable. Now creates a variable called second variable of type int and assigns it the value 50. Now use the /var command to see a list of all previously defined variables and their values. Here we can see all these values. Now we add a literal variable and a second value variable with the plus operator, and the result is saved in the newly created int data type variable sum. Now list again using /var command. Now suppose I change the value of the second variable by multiplying it by 3. For this, we write second variable, then equals sign, then second variable, then multiply sign, and then value 3. In this example, the value of second variable is initially 50. The second line of code multiplies this value by 3 and stores the result 150 back in second variable. After this line of code is executed, the value of second variable is 150. Now we add the new second variable value in sum variable. For this, we write sum equals sum plus second variable. Here the value of sum is initially 72. The second variable is add in this value of sum and stores the result 222 back in sum variable. After this line of code is executed, the value of sum is 222. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Data types in Java. In this lecture, we will talk about primitive data types in Java. Primitives are the most basic data types available in a language and are used to represent simple values such as numbers and characters. In Java, there are 8 primitive data types that are byte, short, int, long, float, double, char, and boolean. Now come to see all these briefly. Byte is a 8-bit signed integer. Short is a 16-bit signed integer. Int is a 32-bit signed integer. Long is a 64-bit signed integer. Float is a single precision 32-bit floating point number. Double is a double precision 64-bit floating point number. Char is a single 16-bit Unicode character. Boolean is a true or false value. What does signed and unsigned mean here? In Java, a signed data type is one that can represent both positive and negative numbers. All of the primitive integer data types, byte, short, int, and long, are signed, which means that they can hold both positive and negative values. An unsigned data type, on the other hand, can only represent non-negative, positive, or zero values. Java does not have any built-in unsigned data types, so you cannot use unsigned values directly in your Java programs. Now start with byte. In Java, a byte is a primitive data type that represents 8-bit signed integer. It can be used to store small whole numbers. A byte is typically used to save space in large arrays. It has a range of values from -128 to 127 and can be used to store small whole numbers, where the memory savings can be significant. Arrays concepts will be discussed in the coming lectures. It is also used when working with binary data, such as reading or writing files. Use example of how you might use a byte in Java. Now open Jshell and write byte b equals 100 semicolon. In this example, the variable b is of type byte and is initialized with the value 100. It easily stores it. If we change the value from 100 to 128 and press enter, It is now given an error. Why? Because it has a range of values from -128 to 127, so it can be used to store small whole numbers only. The next is short data type. In Java, a short is a primitive data type that represents a 16-bit signed integer. It has a range of values from -32,768 to 32,767 and can be used to store small whole numbers. For example, we define a variable with short data type, that is short b equals value 100 and then semicolon. In this example, the variable b is of type short and is initialized with the value 100. It easily stores it. If we change the value from 100 to 32,768 and press enter, it is now given an error. Why? Because it has a range of values from -32,768 to 32,767. So it can be used to store small whole numbers only. The next is int data type. In Java, an int is a primitive data type that represents a 32-bit signed integer. It has a range of values from -2,147,483,648 to 2,147,483,647 and can be used to store whole numbers. An int is the most commonly used integer data type in Java because it provides a good balance between the ranges of values that it can hold and the space that it takes up in memory. For example, type int name I equals then value 1 million and then semicolon. In this example, the variable I is of type int and is initialized with the value 1 million. You can also use the int data type in combination with other data types and operators. For example, int I1 equals value 500,000 and semicolon. Int I2 equals value 250,000 and semicolon. Int I3 equals I1 plus I2 then semicolon. In this example, I1 and I2 are both int variables, and their sum is assigned to I3, which is also an int variable. It is important to note that the int data type should only be used for whole numbers. If you need to store fractional values, you should use a floating point data type such as float or double. The next is long data type. In Java, a long is a primitive data type that represents a 64-bit signed integer. It has a range of values from -9.22337 10 to the power 18 to 9.22337 10 to the power 18 and can be used to store large whole numbers. A long is typically used when an int is not large enough to hold the desired value, or when a program needs to store a large range of whole numbers. For example, write long L equals 10,000 liters then semicolon. In this example, the variable L is of type long and is initialized with the value 10,000. The L suffix indicates that the value is a long literal. You can also use the long data type in combination with other data types and operators. It is important to note that the long data type should only be used for whole numbers. If you need to store fractional values, you should use a floating point data type, such as float or double. The next is float data type. In Java, a float is a primitive data type that represents a single precision 32-bit floating point number. It has a range of values that is approximately plus minus 3.40282347 10 to the power 38 Fahrenheit and can be used to store fractional values. A float is typically used when a program needs to store a decimal value, that is less precise than a double, or when it needs to save space in large arrays. For example, write float f equals value 3.14f then semicolon. In this example, the variable f is of type float and is initialized with the value 3.14. The f suffix indicates that the value is a float literal. It is important to note that the float data type has less precision than a double and may not be suitable for all decimal values. If you need to store a decimal value with higher precision, you should use the double data type. The next is double data type. In Java, a double is a primitive data type that represents a double precision 64-bit floating point number. It has a range of values that is approximately plus and minus 1.797, 10 to the power 308, and can be used to store fractional values. A double is typically used when a program needs to store a decimal value with a high degree of precision, or when it needs to store a very large or very small number. For example, write double variable name d equals value 3.14 and then semicolon. In this example, the variable d is of type double and is initialized with the value 3.14. You can also use the double data type in combination with other data types and operators. It is important to note that the double data type has more precision than a float, but may be slower to execute and may take up more space in memory. If you do not need a high degree of precision, you may be able to use the float data type instead to save space and improve performance. The next is char data type. In Java, a char is a primitive data type that represents a single 16-bit Unicode character. It has a range of values from U0 or 0 to UFFF or 65,535 inclusive, and can be used to store any character in the Unicode character set. A char is typically used to store individual characters, such as letters, digits, and symbols. For example, write char variable c equals 8 then semicolon. In this example, the variable c is of type char and is initialized with the value a. The value of a char is written as a single character, enclosed in single quotes. You can also use the char data type in combination with other data types and operators. It is important to note that the char data type is not the same as the string data type, which is used to store a sequence of characters. A char can only hold a single character, while a string can hold multiple characters. The next is Boolean data type. In Java, a Boolean is a primitive data type that represents a true or false value. It is used to represent the results of a logical operation or a condition. A Boolean can only take on one of two values, true or false. It is typically used in control statements, such as if statements, to determine whether a certain condition is met. For example, write Boolean b equals true semicolon. This b variable only stores a true or false value and nothing else. Now we discuss all 8 primitive data types in Java. Now we discuss string. What is string and why is it not a primitive data type in Java? So the answer is, in Java, a string is a class, not a primitive data type. This means that it is a reference type rather than a value type. A string is a sequence of characters and is used to represent text in a Java program. It is one of the most commonly used classes in Java because it is used to represent text in almost every Java application. The reason that string is not a primitive data type in Java is because it is a more complex data type than the primitive types. It is a class that provides a number of methods for manipulating strings, such as concatenating, comparing, and searching for substrings. For example, create a variable with string s equals hello world, and semicolon. In this example, the variable s is of type string and is initialized with the value hello world. The value of a string is written as a sequence of characters enclosed in double quotes. You can also use the string class in combination with other data types and operators. For example, create three string variables that are string s1 equals hello, string s2 equals world, and then add them. String s3 equals s1 plus s2. In this example, s1 and s2 are both string variables, and their concatenation is assigned to s3, which is also a string variable. The plus operator is overloaded for string objects and is used to concatenate strings. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Primitive data types examples. In this lecture, we will talk about primitive data types examples. We discussed primitive types and their role in Java in the previous lecture. We will now look at some practice exercises. Now start with byte data type. In Java, the byte data type is an 8-bit signed integer. It can hold values from -128 to 127. Here are some examples of how you can combine the byte data type with other primitive data types in Java. Byte plus byte. You can add two byte values together using the plus operator. The result will be of type int. For example, adding two byte values together in Java by creating two variables, x and y, and assigns them values, then stores their results in a sum variable with an int data type. Now create them. For this, open Jshell and write byte x equals value 10, then semicolon, and byte y equals value 20, then semicolon, and then int sum variable equals x plus y, and then semicolon. System.out.print parenthesis variable sum, then semicolon. In this example, the variables x and y are both of type byte. The plus operator is used to add them together, and the result is stored in the sum variable, which is of type int. Note that when you add two byte values together, the result is always of type int. The question is why the result is of type int. In Java, when you add two values of different data types, the result is always of the data type that can hold the largest range of values. This is known as widening primitive conversion. In the case of byte and byte, the result of adding them together will be of type int because the int data type has a larger range of values than the byte data type. We already discussed ranges in the previous lecture. So here is a table showing the range of values for each of the primitive integer data types in Java. As you can see, the int data type has a much larger range of values than the byte data type, so it can hold the result of adding two byte values together without losing any precision. We can add a byte value to a short value using the plus operator. The result will be of type int. For example, adding byte and short values together in Java by creating two variables, x and y. X is a byte and y is a short variable, and assigns values, then stores their results in a sum variable with an int data type. Now create them, that are byte x equals value 10, semicolon, and short y equals value 20 semicolon, and then int some variable equals x plus y then semicolon, system.out.print sum then semicolon. In this example, the variable x is of type byte and the variable y is of type short. The plus operator is used to add them together and the result is stored in the sum variable, which is of type int. Note that when you add a byte value to a short value, the result is always of type int because the short data type is too small to hold the result. Now same as others, like if we can add a byte value to an int value using the plus operator, the result will be of type int because int has a large range compared to a byte. And if we want to add a byte value to a long value using the plus operator, the result will be of type long because long has a large range compared to a byte. And if we want to add an int value to a float value using the plus operator, the result will be of type float because float has a large range compared to a int. And if we want to add a double value to a double value using the plus operator, the result will be of type double. If we check the range of any data type in Java, that is, start from the minimum value to the maximum value. For check minimum value, we can write name of data type, then dot operator, then write min underscore value. And for maximum value, use name of data type, then dot operator, then write max underscore value. Now we check the range of short data type. For this, use this line of code, that is system.out.print parenthesis start double quote, then range of short is colon, and double quote plus short dot min value plus start double quote, and sign max range of short is colon and double quote plus short dot mx value and parenthesis semicolon till o display the range of short data types. This code is printing a message to the console that displays the minimum and maximum values that can be stored in a variable of type short in Java. The short class is a wrapper class for the short primitive data type. It provides several static fields that you can use to access the minimum and maximum values that can be stored in a short variable. We discuss class types in the coming lectures. These fields are min value and mix value respectively. The system.out.print method is used to print the message to the console. The message is a string literal that concatenates the minimum and maximum values using the plus operator. When this code is executed, it will print this message to the console. Short minimum is range minus 32,768 and maximum range is plus 32,767. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Primitive data typecasting in Java. In this lecture, we will talk about the typecasting concept in Java. So, casting in Java is the process of converting one type of data to another. There are two types of casting in Java: widening casting and narrowing casting. The widening casting is a type of casting that converts a smaller data type to a larger data type. This is also known as implicit casting. For example, converting an int to a double. In the previous lecture, we did it similarly too when we added byte and short and saved it as an int data type because int has a larger range than short and byte. To see an example, open Jshell. Now if we create two variables, one of which has an int data type and the other of which has a double data type. Here you can see that we create both variables with different data types in a single line. This is possible in Java because we use a semicolon at the end of both variables and a semicolon ends a statement. Here you can see that a double variable has an automatically assigned value of 0.0. If we declare a variable with no value, the Java compiler will assign it a default value of 0. In the case of int, double, and float, when we declare a character variable as empty, the default value is 000. So the value of I is an int with a value of 123. The value of I is then assigned to the double variable d, without the need for explicit casting. Widening casting is allowed in Java because the range of values for the target data type. In this case, double is larger than the range of values for the source data type, that is int. As a result, the value of I can be safely converted to a double without the risk of data loss. Look at another example. Now we create two variables, short s and int j. The value of the variable s is a short with a value of 100. The value of s is then assigned to the int variable j using widening casting. In this case, the short data type is being converted to an int data type. This is allowed in Java because the range of values for the target data type, in this case int, is larger than the range of values for the source data type, that is short. As a result, the value of s can be safely converted to an int without the risk of data loss. If we convert char to int, see this example. For this, create two variables, char c and int k. The value of the variable c is a char with a value of a. The value of c is then assigned to the int variable k using widening casting. In this case, the char data type is being converted to an int data type. This is allowed in Java because the range of values for the target data type. In this case, int is larger than the range of values for the source data type, in this case, char. As a result, the value of c can be safely converted to an int without the risk of data loss. It's important to note that the value of c is not converted to the character 8, but rather to the ASCII value of a, which is 65. This is because Java stores characters as 16-bit unsigned integers, with each character being assigned a unique ASCII value. ASCII stands for American Standard Code for Information Interchange, is a character encoding standard that represents characters using 7-bit integers. ASCII was originally developed for use with teletypes and is based on the English alphabet. It includes codes for upper and lower case letters, numbers, punctuation marks, and a few special characters. In Java, ASCII codes can be used to represent characters in a char data type. For example, the ASCII code for the letter A is 65, and then we would assign the value A to the variable C. We can also use the char cast to convert an ASCII code to a char data type, like this, int ASCII code equals 65 semicolon, and then write char C equals parenthesis, char ASCII code, then semicolon. In this example, the value of ASCII code is an int with a value of 65. The value of ASCII code is then cast to a char and stored in the variable C. The resulting value of C is A. It's important to note that ASCII is a limited character encoding and does not support characters from other languages or symbols. Unicode, which uses a larger number of bits per character, is a more modern character encoding standard that supports a wider range of characters. The next type is narrow casting. Narrowing casting, the type of casting that converts a larger data type to a smaller one. This is also known as explicit casting. For example, converting a double to an int. It's important to note that casting can result in data loss if the value of the data being converted is not within the range of the target data type. For example, if you try to cast a double with a value of 3.14 to an int, the decimal value will be lost and the resulting value will be 3, as you can see. Now we see another example. In this example, create two variables, float f and int a. The value of f is a float with a value of 3.14f. The value of f is then cast to an int and stored in the variable a. Take note of the most important point is Java does not automatically check if a value fits within the range of a variable, because it is the responsibility of the programmer to ensure that the values assigned to variables are within the appropriate range. For example, if you have an int variable with a range of -2,147,483,648 to 2,147,483,647, it is up to you to make sure that the values you assign to the variable fall within this range. If you try to assign a value that is outside of the range of an int, you will get an error. This is because Java is a statically typed language, which means that the data type of a variable must be known at compile time. This allows the compiler to catch errors, such as out-of-range assignments, and ensures that the code is correct before it is executed. However, it is possible to use typecasting to convert a value to a different data type, even if the value is outside of the range of the target data type. This can be useful in certain situations, but it can also lead to data loss if the value being converted is not within the range of the target data type. It is important to be careful when using typecasting to avoid unintended consequences. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Data types in Java. In this lecture, we will discuss in detail the comparison between the float and double primitive data types. We talked about both of them briefly in the previous lecture on data types in Java, such as their range and definition. So let's talk about the float data type. In Java, a float is a single precision 32-bit IEEE 754 floating point data type. It is used to represent fractional values and is often used in situations where the precision of a double is not required. What does IEEE 754 mean in this context? IEEE 754 is a standard for representing floating point numbers in computers. It specifies the representation of numbers with a fractional component, like 3.14 or 0.1, as well as how to perform operations like addition, subtraction, and multiplication on those numbers. A 32-bit floating point number is a binary number that consists of 32 bits or digits that represent a numerical value. The single precision part of the name refers to the fact that these numbers use a single set of 32 bits to represent the value. The IEEE 754 standard specifies the format for representing these 32-bit floating point numbers. It defines the bits that represent the mantissa, or fractional part of the number, and the bits that represent the exponent or the power of 10, by which the mantissa is multiplied. In Java, the float data type is used to represent single precision floating point numbers. In accordance with the IEEE 754 standard, Single precision means the arrangements, that it consists of one signed bit S, 8 exponent bits E, and 23 mantissa bits M as shown in figure. To see an example, let's open Jshell. Now we create two float variables and print them separately. As we can see here, the float data type is used to represent single precision floating point numbers in Java. A float value must be followed by the letter small f or capital F to indicate that it is a float and not a double. After declaring and initializing the float variables, the code prints their values to the console using the print method. The print method prints the string that is passed to it. So when this code is run, it will print the output to the console. In the preceding example, the first variable value is denoted by a small f and the second by a capital F. The difference is that capital F is the uppercase version of small f, and Java is case sensitive, which means that capital F and small f are treated as two different variables. But it is more common to use small f, since it is easier to type and takes up less space. Here are a few things to keep in mind when working with float values in Java. Float values are represented using fewer bits than double values, so they take up less space in memory. Float values have less precision than double values, which can lead to rounding errors when performing calculations. Float values are generally faster to process than double values on most modern computers, because they take up less space in memory, and the processor doesn't have to do as much work to manipulate them. The main difference between float and double is the range. Float has a lesser range than double. If we want to check the range, we simply use this line of code. As we discussed in the previous lecture on data types in Java, that is system.out.print parentheses, double quotation, and write range of float min range plus float when underscore value plus to max range plus float emma x value parentheses. Now see the range of float here. Look at another example where we used expression. Now we've created a float variable and given it an expression. Now define this variable and press enter. As you can see, it's given an error. That is incompatible types, possible lossy conversion from double to float. Why? Because we do not use f with the value. Without f, it treated as a double and assigned as a float. And double values have a larger range and more precision than float values. This means that when you try to assign a double value to a float variable, you may lose some precision in the process. So we assign f to its value and press enter. Now see another example. In this example, we have a float variable named num is declared and initialized with the result of an arithmetic expression. The expression consists of three parts. In first part, it calculates the result of 4.0 divided by 2.0 and assigns the result to a float value. In second part, it calculates the result of 3.0 multiplied by 5.0 and assigns the result to a float value. And in last part, this adds the results of the two previous calculations together and assigns the result to the float variable num. The final value of num will be 17.0. Now come to double data type. In Java, the double data type is used to represent double precision floating point numbers. It is a 64-bit data type that is used to represent fractional values and is often used when a high level of precision is required. Double precision means it consists of one signed bit S, 11 exponent bits E, and 52 mantissa bits M as shown in figure. For example, we have a double variable named prices declared. and initialized with the value 987, 90D. The capital D or small d suffix is optional when initializing a double value, but it can be included to make it explicit that the value is a double and not a float. We already discussed explicit and implicit concepts in the typecasting in Java lecture. Now take a slightly more complex calculation example. In the example, it calculates the total price of an item by adding the price of the item to the price of the tax. The result is stored in a double variable named total and printed to the console using the print method. The code starts by declaring a double variable named tax rate and initializing it with the value 0.09. This represents the tax rate as a decimal value. Then it declares a double variable named total and initializes it with the result of the expression price plus parentheses price multiply tax rate. We already initialized the price variable. This calculates the total price of the item by adding the price of the item to the price of the tax, which is calculated by multiplying the price by the tax rate. Finally, the code uses the print method to print the value of total to the console along with the string total. The print method prints the string that is passed to it, followed by a new line character. So if the value of price is 987, 90D, and the value of tax rate is 0.09, the output of this code is total is 1076.811 as you can see it. Here are a few things to keep in mind when working with double values in Java. Double values are represented using 64 bits, which is twice as many bits as float values. This means that double values have a greater range and precision than float values. Double values are generally slower to process than float values on most modern computers because they take up more space in memory, and the processor has to do more work to manipulate them. Double values are often used in situations where a high level of precision is required, such as when working with very large or very small numbers, or when performing a large number of calculations. The main difference between float and double is the range. Double has a higher range than float. If we want to check the range, we simply use this line of code, that is, system.out.print parentheses, double quotation, and write range of double min range plus double then underscore value plus to max range plus double IMf&x value parentheses. Now see the range of double here in the final section of this lecture. In summary, we will compare float and double data types. Now take a look at their differences. The first point defines the characteristics. The second point discusses floating, and the third point discusses doubles. First is memory. Float occupies 4 bytes of memory, while double occupies 8 bytes of memory. Next is accuracy. Float accuracy is low, while double accuracy is high. Next is precision. Float follows single precision, while double follows double precision. Next is keyword used. The float keyword is used to define a float number, while the double keyword is used to define a double precision number. Next is default data type. Java does not use it as the default floating point number, while double is the default data type for floating point numbers. Next is data loss. There will be no data loss if we convert float to double, while there will be data loss if we convert double to float. Next is uses. Float should be used where less accuracy is required and storage is a constraint, while double is used where more accuracy is required and also requires more precision. Last one is suffix. Float uses capital F or small f as a suffix. It is mandatory to add a suffix if you are declaring a float variable, while double uses small d or capital D as a suffix. It is optional to add a suffix if you are declaring a double variable. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Data types in Java. Scientific notations in float and double. In this lecture, we will use scientific notations in float and double. First, we discuss about scientific notation. Scientific notation is a way of representing very large or very small numbers in a more convenient and compact form. It is commonly used in mathematics, science, and engineering. In scientific notation, a number is represented as a base number, multiplied by a power of 10. The base number is always between 1 and 10 inclusive, and the power of 10 is expressed as an exponent. For example, the number 123,456,789 can be written in scientific notation as 1.23456,789 multiply 10 to the power 8. The base number is 1.23456,789, and the exponent 8 indicates that the number should be multiplied by 10 raised to the 8th power or 10 to the power 8. Scientific notation is often used to represent very large or very small numbers in a more manageable form. For example, the distance from the Earth to the Sun is about 93 million miles, which can be written in scientific notation as 9.3 multiply 10 to the power 7 miles. In programming, scientific notation can be used to represent floating point numbers in certain programming languages, such as Java. Now we understand this concept with the help of some examples. For this, open Jshell. Now look at the first example. If we store a large number in a double variable, then double store it in scientific notation. For example, we create a double variable and store a big value like this. Here you can see this, the value 2, and then some point values, and then E10 is a number in scientific notation, which is a way of representing very large or very small numbers in a more compact form. In scientific notation, a number is represented as a mantissa, a decimal number multiplied by the base 10 raised to an exponent. In this case, the mantissa is 2, and point values, and the exponent is 10, so the value of the number is 2. And point values multiply 10 to power 10, or 2 and point values E10. The value of num would be equivalent to our given number. In the next example, we multiply two scientific notation numbers. For this, declares a variable num1 of type double, and assigns it the result of the multiplication. For 56E10 multiply 5, 8099. The values for 56E10 and 5, 8099 are numbers in scientific notation, which is a way of representing very large or very small numbers in a more compact form. In scientific notation, a number is represented as a mantissa, a decimal number multiplied by the base 10 rose to an exponent. In this case, the mantissas are 4.56 and 5.89, and the exponents are 10 and 9 respectively. The value of num1 would be the result of 4, 56E10 multiply 5, 8099 is 2, 68584E20. In the next example, we calculate the circumference of a circle in the given the radius. For this, we first declare a variable pi with double data type and assign it the value 3.14, which is a common approximation of the mathematical constant pi. It then declares a double variable, radius, and assigns it the value 5000, which represents the radius of the circle. Next, we calculate the circumference of the circle using the formula 2 multiply pi multiply r, where pi is the value of pi and r is the radius of the circle. The result is stored in the double circumference variable. Finally, the code prints the value of the circumference variable to the console using the print method of the system.out.Object. The print method prints the value. In the next example, we will convert Celsius to Fahrenheit. To convert a temperature from Celsius to Fahrenheit, you can use this formula. Fahrenheit equals parentheses 9.0 divided by 5.0 multiply Celsius plus 32. For this, we declare a variable Celsius of type double and assign it the value 37.5, which represents a temperature in Celsius. Then declares a variable Fahrenheit of type double and assigns it. The result of the conversion from Celsius to Fahrenheit. The formula for converting a temperature from Celsius to Fahrenheit, that is, double F equals parentheses 9 divided by 5 multiply Celsius plus 32, where F is the temperature in Fahrenheit and Celsius is the temperature in Celsius. Then calls the print method of the system.out.Object, which prints the value of the Fahrenheit variable to the console. The print method prints the value. The result of this code would be the temperature in Fahrenheit, which would be a double value, as you can see. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Char versus string. In this lecture, we will discuss in detail the comparison between the char and string primitive data types. First, we discuss the char primitive data type. A character is a unit of information that represents a single symbol in a written language. Characters can include letters, digits, punctuation marks, and other symbols used in written communication. In Java programming language, characters are represented using the char data type. The char data type is a single 16-bit Unicode character, and single quotes are used to denote a char literal, which allows for a range of 65,536, that is 210 to the power 16, unique characters including most of the world's written languages, as well as special characters and symbols. Characters are used in Java programming language to store and manipulate text data. To see an example, open Jshell. Here we create char variable ch is being declared and initialized with the value a in single quote. Then write system.out.print parenthesis ch semicolon. The print method of the system.out.Object is being called to print the value of the ch variable to the console. Remember that in contrast, double quotes are used to denote a string literal. A string is a sequence of characters represented by a series of characters in double quotes, and we will discuss string later. Now come to the char again. So there are several ways in which the char data type can be used in Java. Like, the char data type is well suited for storing and manipulating individual characters, such as letters, digits, and punctuation marks. For example, you might use a char variable to store a user's initial, or a single character from a longer string. The char data type can be used to represent special characters in a string using escape sequences. An escape sequence is a combination of characters that represents a special character, such as a new line or a tab. For example, you can use the escape sequence \n to represent a new line character in a char literal. The char data type can be used to implement algorithms that operate on individual characters, such as character sorting. Now we will discuss Unicode because Java supports it for char values. What is Unicode? Java supports a Unicode value for characters, which you can use to set a char value. Unicode is an international encoding standard for use with different languages and scripts, by which each letter, digit, or symbol is assigned a unique numeric value that applies across different platforms and programs. In the English alphabet, only 26 characters are needed in total to represent the entire English alphabet. But other languages need more characters, and often a lot more. Unicode allows us to represent these languages. The way it works is that by using a combination of the 2 bytes that a chart takes up in memory, it can represent any one of 65,535 different types of characters. Let's swing over to the browser and look at a website called unicode-table.com. Here we can see there that we've got a lot of symbols on the screen. And if we scroll down, you can see there's lots of different symbols. And these are all Unicode characters. And you can see there are many characters. And as I'm scrolling down, that's actually generating more. So I'll go back up to the top again. Let's find the Unicode value for the capital letter C. There are actually different ways to get the value. The quickest way to get the values is to left-click on the letter of interest. A small pop-up will appear with 2 values. The first value that starts with U+ has the Unicode value. After the U+, so we are interested in the value 0043. Now that we have the code, how do we use it in Java? We'll put the single quotes as we did before. But this time, because we're putting in a Unicode character, we need to put a \u and those 4 digits all in single quotes. Now we use it in program. For this, we have the char variable Unicode is being declared and initialized with the Unicode value single quote \u0043. The \u escape sequence is used to represent a Unicode character in a char literal. The 4-digit hexadecimal number 0043 and \u represents the Unicode code point for the character. The Unicode code point 0043 represents the character capital C. Therefore, the char variable Unicode will be initialized with the character capital C. Here we can see it stores character capital C. So, there are 3 ways to assign a value to a character: a literal character, a Unicode, and an integer. We already discussed literal characters in Unicode, but how is an integer possible? Because the range of the char data type includes all of the ASCII characters, which are the first 128 characters in the Unicode character set. For example, let's make a char variable called ASCII and give it the value 65. Decimal 65 have the character capital A in the ASCII table, so you can see it with a capital A here. Now come to string in Java. So, a string is a sequence of characters. In Java, string is not a primitive data type. It is a class in the Java library that represents a sequence of characters, and double quotes are used to denote a string literal. It is also called a non-primitive data type. We will discuss all non-primitive data types later. Why we discuss this here is because it is very important, because we start our first program with it, which is hello world, and hello world is a string. That is a sequence of characters. For example, we have the string variable company is being declared and initialized with the value Java programming with Nixware. The string literal is a series of characters in double quotes, and it represents the string value Java programming with nixware. Now you can see it store nixware as a string. Now see another example. We have three string variables s1, s2, s3 are being declared and initialized with the values that are hello, world, and program respectively. Then write print method of the system.out.Object is being called one by one to print the values of the string variables to the console. The print methods print the given strings to the console, that is hello, world, and program. Now see another example. Here we have three int variables num1, num2, and sum. Num1 and num2 are being declared and initialized with the values 100, 200. Then plus operator is being used to add the values of num1 and num2 and assign the result to the int variable sum. Then write system.out.print parenthesis double quote sum is plus sum semicolon. Here the print method of the system.out.Object is being called to print the string the sum is and the value of the sum variable to the console. Here the plus operator concatenates the value to the string that is sum is colon. Here is the output. Now take a quick look at the summary of the difference between char and string. Char is a primitive data type, while string is a non-primitive data type. Char stored a single character, while string stored a sequence of characters. Char enclosed in single quotation, while string enclosed in double quotation. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Summarizing primitive data types. In this lecture, we will summarize the primitive data types that we discussed in the previous lectures. Now we should be aware with all of the Java primitives at this stage. So let's go through the basic types that we previously worked with, including the byte, short, int, long, float, double, char, and boolean. As we've covered in earlier lectures, each of these basic types has a specific size and provides a variety of purposes. Let's start with byte and Java. A byte is a primitive data type that occupies 8 bits of memory and is used to store signed integers in the range -128 to +127. Bytes are often used to represent a small, compact piece of data, such as a single character or a small integer. In a larger program, they are also useful for working with binary data, such as files or network streams, because they can store a single byte at a time. Next is short. In Java, a short is a primitive data type that occupies 16 bits of memory and is used to store signed integers in the range -32,768 to +32,767. Short values are similar to byte values in that they are used to represent small, compact pieces of data, but they are larger and can store a wider range of values. Like bytes, shorts are often used to work with binary data, such as files or network streams, because they can store a single short value at a time. Shorts are also used as the basic unit of memory allocation in some situations, such as when working with arrays of short values. Next is int. In Java, an int is a primitive data type that occupies 32 bits of memory and is used to store signed integers in the range minus this number to plus this number. Int values are used to represent whole numbers, such as 3 minus 5 or 0. They are the most commonly used integer data type in Java and are used in a wide variety of applications. Int values are often used as the basic unit of memory allocation in Java, as they can be used to represent the size of an object or an array in memory. They are also commonly used in arithmetic operations, as they can store large numbers and can be processed quickly by most modern computers. Next is long. In Java, a long is a primitive data type that occupies 64 bits of memory and is used to store signed integers in the range minus this number to plus this number. Long values are similar to int values in that they are used to represent whole numbers, but they are larger and can store a wider range of values. Long values are often used when a program needs to store a very large integer value that is outside the range of the int data type. They are also used in situations where the program needs to store a value that will not fit in an int, such as the number of seconds in a year. Like int values, long values are often used in arithmetic operations and are processed quickly by most modern computers. Next is float. In Java, a float is a primitive data type that occupies 32 bits of memory and is used to store single precision floating point numbers. Floating point numbers are numbers that have a decimal point, such as 3.14 or minus 0.01. They are called floating point because the decimal point is said to float within the number depending on the magnitude of the value. Float values are used to represent approximate numeric values, such as the result of a mathematical calculation or the value of a measurement that has been rounded off. Float values are often used when a program needs to store a number with a fractional component, but the precision of the number is not critical. Next is double. In Java, a double is a primitive data type that occupies 64 bits of memory and is used to store double precision floating point numbers. Double precision numbers are similar to single precision numbers, represented by the float data type, but they are larger and have more precision, which means that they can store a wider range of values and maintain a higher level of accuracy. Double values are often used when a program needs to store a number with a fractional component and a high level of precision, such as the result of a complex mathematical calculation. They are also used when the range of possible values is very large, as they can store larger numbers than the float data type. Next is char. In Java, a char is a primitive data type that occupies 16 bits of memory and is used to store a single Unicode character. Unicode is a standardized encoding system that represents characters from a variety of scripts, including the Latin alphabet, Greek alphabet, and Chinese characters. Char values are used to represent characters such as letters, digits, and punctuation marks in a Java program. They are often used to store text data, such as the characters in a word or a sentence, and are used in a variety of applications, such as text processing and output to the console. Char values are also used to store special characters, such as escape sequences, which are used to represent non-printable characters or to perform certain actions in a program. Next is Boolean. In Java, a Boolean is a primitive data type that occupies 1 bit of memory and is used to store the values true and false. Boolean values are used to represent the truth or falsity of a statement or condition in a Java program. They are often used to control the flow of a program, such as in a conditional statement or a loop. by testing the value of a Boolean expression and executing different code based on the result. Boolean values are also used to store the results of comparisons and other logical operations, such as greater than or equal to, because they occupy only one bit of memory. Boolean values are an efficient way to store and manipulate simple true and false values in a program. Next is string. In Java, a string is an object that represents a sequence of characters. Strings are used to store and manipulate text data in a Java program. They are created by enclosing a sequence of characters in quotation marks and are commonly used to store names, words, sentences, or other pieces of text. Java strings are immutable, which means that once a string object is created, its value cannot be changed. Instead, a new string object must be created to represent a modified version of the original string. This is different from some other programming languages, where strings can be modified in place. Java provides a number of methods for working with strings, such as concatenation, substring extraction, and search and replace. Strings are also commonly used in combination with other Java features such as regular expressions and string formatting. I hope you learned something useful in this lecture as well, and I'll see you in the next one. What are operators? In this lecture, we will talk about operators in Java. In Java, an operator is a symbol that performs a specific operation on one, two, or three operands and produces a result. There are many operators in Java. For example, D equals A plus B multiply C semicolon. In this statement, D is a variable, and A, B, and C are also variables or values. The statement uses the assignment operator, equals to assign the value of the expression. A plus B multiplies C to the variable D. First, the value of B multiply C is calculated, since the multiplication operator has higher precedence than the addition operator plus. Then the value of plus B multiply C is calculated as A plus parenthesis B multiply C. Finally, the value of the expression is assigned to the variable D. So the value of D will be the result of the addition of A and B multiply C. Now we can see three operators here, equal, plus, and multiplication, and four operands that are A, B, C, and D. The term operand is used here. So what exactly is operand? In Java, an operand is a quantity on which an operation is performed. An operator performs an operation on one or more operands to produce a result. For example, in the expression 5 plus 2, 5 and 2 are the operands and plus is the operator. The operation performed is addition, and the result of the operation is 7. In this expression, 5 and 2 are both values, also known as literals, but operands can also be variables. For example, in the expression x plus y, x and y are variables that represent values, and the operator plus performs the operation of addition on those values. Operands can be of various types, such as integers, floating point numbers, characters, and strings, depending on the operation being performed. For example, in the expression double quote hello plus double quote world, the operands are strings, and the operator plus concatenates or joins them to produce the result, hello world. Now we define what an expression is in Java. An expression is a combination of variables, literals, and operators that represents a single value or operation. Expressions are used to perform operations and to specify values in Java programs. An expression can be a simple value, such as a literal or a variable, or it can be a more complex combination of values and operators. For example, the expression 15 plus 12 represents the operation of adding the values 15 and 12. The result of this expression is 27. Expressions are often used in Java statements, such as assignment statements and control statements. For example, in the assignment statement, x equals 15 plus 12, the expression 15 plus 12 is evaluated, and the result is assigned to the variable x. Now open Jshell. We create a variable with value that is in sum equals 6 plus 7, semicolon, and the double slash. Notation indicates the start of a single line comment. Anything after the double slash on the same line is considered a comment and is ignored by the compiler. Here the comment 6 plus 7 equals 13 is added to explain the purpose of the code. It does not have any effect on the execution of the program. Here int is a Java keyword that indicates that a variable of type integer is being declared. Sum is the name of the variable that is being declared, and initialized equals is the assignment operator, which assigns a value to a variable 6 plus 7 is the expression that is being evaluated, and assigned to the variable sum. The expression 6 plus 7 consists of 6 and 7 are the operands. They are integer values, also known as literals. Plus is the operator. It performs the operation of addition on the operands 6 and 7. The result of the expression 6 plus 7 is 13, which is then assigned to the variable sum using the assignment operator equals. So after this statement is executed, the variable sum will have a value of 13. Now we discuss comments in Java as we used them in the previous example. A comment is a piece of text in a program's source code that is not executed as part of the program. Comments are used to add explanatory notes to the code and to document how the code works in Java. Comments are used to explain the purpose of the code, how it works, and any important implementation details. Comments are ignored by the compiler and are not included in the final executable version of the program. They are intended for human readers of the code and are used to help make the code easier to understand. There are two types of comments in Java: single-line comments and multi-line comments. Single-line comments start with two forward slashes dot and continue until the end of the line. Multi-line comments start with a forward slash and an asterisk, and end with an asterisk and a forward slash. They can span multiple lines. For example, we have a variable x of type int and initialize it with the value 10. The lines starting with double forward slash are comments and are ignored by the compiler. They are used to add explanatory notes to the code. Double forward slash declare a variable. This line is a comment that explains the purpose of the line of code. A forward slash and an asterisk. This is the start of a multi-line comment. Everything between the opening, a forward slash and an asterisk, and closing asterisk, and a forward slash is considered a comment and is ignored by the compiler with the value 10. Asterisk and a forward. This line is part of the multi-line comment started on the previous line. It explains the purpose of the next line of code, x equals 10 semicolons. This line initializes the variable x with the value 10. System.out.print parenthesis x semicolon. This line prints the value of x to the console. / print the value of x to the console. This line is a comment that explains the purpose of the next line of code. Now come to the operator again and see an example. We have two variables. First value and second value are declared and initialized with the values a and b respectively. The variables first value and second value are of type char, which represents a single character in Java. The line system.out.prints parentheses first value plus second value prints the sum of first value and second value to the console. Since first value and second value are of type char, their sum is actually the result of adding their ASCII values. For example, the ASCII value of A is 65 and the ASCII value of B is 66. Therefore, the expression first value plus second value evaluates to 65 plus 66, which is 131. Now it prints 131 to the console. Remember that chars never concatenate here with the plus operator, unless we use string here like this. When we use the line system.out.print parenthesis empty string plus first value plus second value prints the concatenation of first value and second value to the console. Since the empty string is added to the beginning of the expression, the result of the expression is a string. Here it prints A/B to the console. Now use another operator, which is subtraction in Java. The subtract operator is used to perform subtraction. It can be used with numeric operands, such as int and double, to subtract one number from another. For example, we have three variables, x, y, and z, are declared and initialized. The variables x and y are initialized with the values 10 and 5 respectively. The variable c is then assigned the value of x minus y, which are 10 minus 5. Then print the z variable using the print method. Here is the output 5. Look another operator, that is multiplication in Java. The multiplication operator is used to perform multiplication. It can be used with numeric operands, such as int and double, to multiply one number by another. For example, we have variables x and y are declared and initialized with the values 10 and 5 respectively. The variable c is then assigned the value of x multiply y, which is 10 multiply 5, that is 50. Another example, write int r equals 10 semicolon. This line declares a variable r of type int and initializes it with the value 10. Then write int d equals r multiply r semicolon. This line declares a variable d of type int and assigns it the result of multiplying r by itself 3 times, which is 10 multiply 10 multiply 10, that is 1000. /d is assigned the value of 10 multiply 10 multiply 10, which is 1000. This line is a single line comment that explains the purpose of the previous line of code. Now we see another operator, that is modulus, means remainder in Java. The modulus operator is used to obtain the remainder of a division operation. It can be used with numeric operands, such as int and double, to divide one number by another and return the remainder. For example, we have three variables, x, y, and z are declared and initialized. The variables x and y are initialized with the values 10 and 3, respectively. The variable z is then assigned the value of x modulus y, which is 10 modulus 3, that is 1. Why is the answer 1? Because 3 does not completely divide the 10. When we multiply 3 by 3, we get 9, which we subtract from 10, and 1 is remaining. Similarly, if we divide 2 by 10, the remainder is 0. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Arithmetic operators. In this lecture, we will talk about arithmetic operators in Java. In Java, there are several types of operators like arithmetic operators, relational operators, logical operators, assignment operators, conditional operators, bitwise operators, ternary operator, instance of operator. We will define all these in little bits and discuss them in detail in coming lectures. Here we will discuss only the arithmetic operator in detail. So we take a look at all of these. Arithmetic operators. These are used to perform basic arithmetic operations, such as addition, subtraction, multiplication, division, increment, and decrement. Relational operators. These are used to compare two values and determine their relationship, such as whether one value is greater than, less than, or equal to another value. Logical operators. These are used to combine two or more relational expressions and determine their overall truth value. Assignment operators. These are used to assign a value to a variable. Conditional operators. These are used to perform different actions based on the truth value of a condition. Bitwise operators. These are used to perform bit-level operations on integer values. Ternary operator. This is a conditional operator that takes three operands and evaluates a Boolean expression, returning one value if the expression is true, and another value if it is false. Instance of operator. This is used to determine if an object is an instance of a particular class or an implementation of a particular interface. Now we will discuss arithmetic operators and some others in detail, and also write multi-line example code in Jshell using curly braces. For this, we first discuss what curly braces are and how we can use them in Jshell. Curly braces are used to group statements together as a block. This is useful when you want to execute multiple statements as a single unit. Open Jshell to look at an example. Now write start curly brace for block of statements. Within the curly braces is executed. Then two integer variables, first variable and second variable, are declared and initialized with the values 2 and 3 respectively. Then variables first variable and second variable are added together, and the result is stored in the sum variable. Then the string result is, and the value of the sum variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Now we can see the output, that is, result is 5. Look at another example. Now write start curly brace for block of statements. Within the curly braces is executed. Then integer variable number is declared and initialized with the value 1. Then value of number is incremented by 1, resulting in a new value of 2. Then the string result is and the value of the number variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. So the output is, result is 2. The statement number equals number plus 1 is working as increment operator in Java. Now we discuss increment operator in Java. The increment operator is a unary operator that is used to increase the value of a variable by 1, that also known as plus plus. There are two increment operators in Java: the postfix increment operator and the prefix increment operator. The postfix increment operator increments the value of a variable by 1, but the increment occurs after the value of the variable has been used in the expression. For example, int x equals 5, then semicolon, int y equals x plus plus semicolon. First y is assigned the value of x, which is 5, and then x is incremented to 6. The prefix increment operator increment the value of a variable by 1, but the increment occurs before the value of the variable is used in the expression. For example, int x equals 5 semicolon, int y equals plus plus x semicolon. First x is incremented to 6 and then y is assigned the value of x, which is 6. There is another way to increment value by 1 is compound assignment operator with the plus sign. In Java, the compound assignment operator with the plus sign is the plus equals operator. It is used to add the right operand to the left operand and assign the result to the left operand. For example, int x equals 10 semicolon, int y equals 5 semicolon, x plus equals y semicolon. X is now 15. This is equivalent to writing x equals x plus y semicolon. The compound assignment operator with the plus sign can be used with any primitive type or with variables of type integer and atomic integer. The compound assignment operator with the plus sign is a shorthand way of adding a value to a variable and assigning the result to the same variable. It is often used in loops to accumulate the sum of a series of values or to perform some action repeatedly on the same variable. Look at another example of this open Jshell. Now write start curly brace for block of statements. Within the curly braces is executed. Then integer variable my number is declared and initialized with the value 10. The value of number is incremented by 1 using the postfix increment operator plus plus, resulting in a new value of 11. Then the string result is, and the value of the my number variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Here we can see the output, that is 11. Now edit the same example again and change only statement with compound assignment operator with the plus sign, that is my number plus equals 1 semicolon. Now press enter. The same result is shown here. Now look at another arithmetic operator, that is decrement operator in Java. There are two decrement operators, the postfix decrement operator minus minus and the prefix decrement operator minus minus. The postfix decrement operator minus minus decrements the value of a variable by 1, but the decrement occurs after the value of the variable has been used in the expression. For example, int x equals 5 semicolon, int y equals x minus minus semicolon. First y is assigned the value of x, which is 5, and then x is decremented to 4. The prefix decrement operator minus minus decrements the value of a variable by 1, but the decrement occurs before the value of the variable is used in the expression. For example, int x equals 5 semicolon, int y equals minus minus x semicolon. First x is decremented to 4, and then y is assigned the value of x, which is 4. Look at another example. Now write start curly brace for block of statements within the curly braces is executed. Then integer variable my number is declared and initialized with the value 10. The value of number is decremented by 1 using the postfix decrement operator minus minus resulting in a new value of 9. Then the string result is, and the value of the my number variable are printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Here we can see the output, that is 9. Now edit the same example again and change only statement with compound assignment operator with the minus sign, that is my number minus equals 1 semicolon. Now press enter. The same result is shown here. The compound assignment operator is used with the different arithmetic operator signs like plus, minus, multiply, and division. We already practiced of the compound assignment operator with the plus sign and compound assignment operator with the minus sign. Now we look at the compound assignment operator with the multiply sign. For this, open Jshell. Now we have variables x and y are declared and initialized with the values 10 and 5 respectively. Then compound assignment operator multiply equals is used to multiply the value of x by the value of y and assign the result back to x. The value of x is now 50 and the value of y remains unchanged at 5. Then the string result is, and the value of the x variable is printed to the console using the system.out.print statement. And last, close the curly brace to end the block and press enter. Here we can see the output, that is 50. Now we look at the compound assignment operator with the division sign. Now edit same example. Only change division sign here and press enter. Here we can see the output, that is 2. Look another example using decimal number. Now write start curly brace for block of statements within the curly braces is executed. We have declaring a variable point number of type double and initializing it with the value 5.5. Then using the compound assignment operator plus equals to add 4.5 to the value of point number and assign the result back to point number after this operation. The value of point number becomes 10.0. Then using the system.out.print method to print the string, result is, followed by the value of point number. And last, close the curly brace to end the block and press enter. Here we can see the output, that is 10.0. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to IDE. In this lecture, we will go over an introduction to IDE. In the previous lectures, we learned the basic concept of Java using the very basic tool Jshell. Now we can move on to learn advanced Java concepts and write complete and comprehensive Java code. For this, we now will use an IDE. So, what is an IDE and why do we use it? An integrated development environment IDE is a software application that provides a comprehensive set of tools for software development. IDEs typically include a code editor, a compiler or interpreter, and a debugger, as well as many other features such as a source code management system, a version control system, and a build automation system. The main benefit of using an IDE is that it provides a single, unified interface for all the tasks involved in software development. This can save a lot of time and effort, as developers do not have to switch between different tools or environments for different stages of the development process. IDEs can also provide helpful features such as code completion, syntax highlighting, and error checking, which can make it easier and more efficient to write, debug, and maintain code. There are many different IDEs available for different programming languages and platforms. Some popular IDEs for Java include Eclipse, NetBeans, and IntelliJ IDEA. We will now work on IntelliJ IDE because of a variety of reasons. IntelliJ IDE is a popular Java integrated development environment developed by JetBrains. It is widely used by Java developers because of its rich set of features and functionality. Some of the benefits of using IntelliJ IDE include intelligent code completion. IntelliJ IDE provides intelligent code completion that suggests names of variables, methods, and classes as you type. This can help you write code more quickly and accurately. Advanced refactoring tools. IntelliJ IDE has advanced refactoring tools that can help you safely and easily change the structure of your code. Built-in debugger. IntelliJ IDE has a built-in debugger that allows you to step through your code, set breakpoints, and inspect variables. Integrated version control. IntelliJ IDE integrates with version control systems such as Git and Mercurial, allowing you to easily manage your codebase and collaborate with others. Customizable user interface. IntelliJ IDE has a customizable user interface, so you can tailor it to your specific needs and preferences. Great support for popular frameworks and libraries. IntelliJ IDE has excellent support for popular Java frameworks and libraries such as Spring, Hibernate, and Android. Regular updates and improvements. JetBrains is actively developing and improving IntelliJ IDE, releasing new versions on a regular basis. To summarize it, look at the difference between an IDE and a text editor. IDE typically includes a code editor, compiler or interpreter, and debugger, while text editor is a simple program for creating and editing plain text files. IDE provides a comprehensive set of tools for the full software development life cycle, while text editor may have basic features such as syntax highlighting and code folding. IDE may have features such as code completion, syntax highlighting, and error checking, while text editor does not typically include a compiler or debugger. IDE may include tools for source code management, version control, and build automation, while text editor does not have as many tools and features as an IDE. IDE may be more feature-rich and have a steeper learning curve, while text editor may be simpler and easier to use. I hope now you can see why we are going to use an IDE rather than a text editor. So, in the next lecture, we will install the IntelliJ IDE on Windows and then on Linux. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Hello World and IDE. In this lecture, we will go over an introduction to the program Hello World and IDE. We executed our first Java code in IntelliJ during the last lecture. We'll take a closer look at the source code for this class as it is currently shown in IntelliJ in this lecture. You'll quickly note that the code is shown using a variety of fonts and colors, and that it is well written with indentation. Whenever we produce the text in the file in that manner, IntelliJ will format it for us in this case. When viewing the code, we can see that there are public and class elements. The public keyword is an access modifier that controls the access level of a class, method, or field. When a class is declared with the public keyword, it means that the class can be accessed from anywhere in the code, both within the same package and from other packages. Access modifiers are used to define which parts of our code, or even someone else's code, can access a particular element. The class keyword is used to define a new class in Java. The class name follows the keyword, and a class is a blueprint for creating objects, a particular data structure, providing initial values for state member variables or fields, and implementations of behavior member functions or methods. The left and right curly braces are used to define the class body, which contains the fields and methods that make up the class, and anything within the curly braces is considered part of the class definition. A class definition also requires an optional access modifier at the start. In this case, public is used to grant full access, as mentioned in the statement. It's also mentioned in the statement that this information is an overview, and that more details about access modifiers and class definition will be discussed later. Now, anything inside of that body between the left and right curly braces is regarded as belonging to this class. As we go through the course, you'll find that a class may include both data and code. We now have a clear definition of our first class in our first project. We can also see that this class has a main function that prints our hello world message. But let's define a method first. A method is a group of statements, one or more of which carry out an action. We'll be utilizing the main method, a unique method that Java searches for while executing a program. It serves as the starting point for all Java code, and whenever we use it, Java searches for the main method to launch and execute the application. As you'll see later, you may even develop your own ways. Let's discuss this method and the keywords that appear before the method name, main. In this case, the first thing to notice about this line is that the access modifier public, which we covered when establishing the class, means that other code may access this function. To fully grasp the Java term static, one must be familiar with other object-oriented IDEs. So, for now, simply be aware that static is required for Java. To locate this unique method and execute the new code, the following Java keyword further indicates that the procedure won't return any data. But once again, we'll go into it in more detail later. You may be sure that at the appropriate time in the course, we'll be going into great depth about all of these topics. Moving on, we have the previously discussed left and right parentheses, which are required for a method declaration. And that is what we are doing here. We are defining a method by including this code. To give information to a method, you may optionally specify one or more parameters, in addition to the left and right parentheses, which are required. As you can see, one parameter has been created. We'll discuss these parameters, leaning in more detail later. Now, the main method must be written exactly, as it is here in order for Java to describe it. Now, if you enter anything different, for instance, if you use a capital C, IntelliJ will inform you that it doesn't comprehend the term class, with a capital C by immediately underlining it in red when you do so. However, if we convert it back to the lowercase c it was originally, it becomes very satisfied and the issue is fixed. So have that in mind, as you'll often discover that mistakes may often be attributed to your mistakenly entering something in capital or lowercase. You'll see that the left and right curly braces that we use to group statements together in the Jshell lecture are still there in the main method declaration there on line 2. This also goes by the name code block, and in this instance, the method body serves as the code block. The code block may now be used to properly define the beginning and end of a method, and statements can be used to insert code within the block. Now for practice, we change an hello world statement and add a world Nixware company. Now run it. Here we can see the output. Next I want to show you again how to create a class in IntelliJ. So first we want to right click on the src folder in our project, and we'll see new. That's the first option. Clicking that, it will give us the option of requesting a name, and highlight the class option below it by default. We'll put in a name. I'm going to call this my class, and press enter after that. Now again, you'll see my class listed under the src folder with a little blue C icon beside the name, indicating it's a class. And now you can see in the edit window that we have our class name like class, and other than this first line and the curly braces, the rest of the window is pretty much empty. Now I want to add two statements to the output, so let's do that by writing method public static void main parentheses string square brackets arcs opening the curly brace. Then write system.out.print parentheses double quotes, write string hello comma nixware semicolon. Then in the second line, same print statement repeats with different string, that is, American company. Then closing the curly brace. Now let's run that by clicking the green arrow. Now it's run successfully, and you can see the outputs printed on the same line. But I wanted Nixware Company to print on another line. In the previous lectures, we've only used system.out.print. But as you can see from this example, if you use multiple statements like this just prints everything on the same line. To print Nixware Company in next line, we just add ln in first line. ln means the next line, or simply breaks line. Now run it again by clicking the green arrow. Now it's run successfully, and you can see the outputs printed on the two different lines. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Logical operators. In this lecture, we will discuss logical operators in Java. In the previous lecture, we discussed the if-then condition and used some operators to learn the concept of the if-then condition. Now, we learn about the logical operator and see how we can use it. In Java, logical operators are used to perform logical operations on Boolean expressions. They are used to combine multiple conditions in an if statement or a loop, or to negate a Boolean value. The logical operators that are available in Java are an operator. This operator is used to check if both the conditions are true. If both conditions are true, then the entire expression returns true. Or operator. This operator is used to check if either of the conditions is true. If any one of the conditions is true, then the entire expression returns true. Not operator. This operator is used to negate a Boolean value. If a condition is true, then the not operator will make it false, and vice versa. Some other are working on bitwise logical operator, like bitwise and bitwiser operator. In Java, bitwise logical operators are used to perform operations on individual bits of a binary number. These operators work on the binary representation of the numbers and allow you to manipulate the bits directly. Bitwise logical operators are typically used in low-level programming, such as working with hardware devices, or in performance-critical code, where manipulating the bits directly can be faster. And using the higher-level operators, it's also used in some cases where the bit manipulation is needed, such as in encryption and compression algorithms. So, we will discuss bitwise logical operators later. Logical operators are important in Java because they allow you to create complex conditional statements and control the flow of execution of your program. They allow you to check multiple conditions and make decisions based on the result of those conditions. They can simplify complex expressions by breaking them down into smaller, more manageable parts. They also make your code more readable and maintainable. Logical operators are also useful for improving the performance of a program, as they allow you to evaluate multiple conditions in a single statement and avoid unnecessary computation. Furthermore, logical operators are versatile and can be used in a wide variety of situations, such as in if-else statements, while loops, and for loops. This makes them a powerful tool for programmers to use in many different types of applications. So, there are a few potential limitations of using logical operators in Java, like complexity. Logic operators can make code more complex and harder to understand, especially when multiple conditions are combined in a single expression. Error-prone. Logic operators can be difficult to use correctly, and using them incorrectly can lead to bugs and errors in your code. Performance. Using too many logical operators can slow down the performance of a program. Confusion. Logic operators can be confusing to new programmers, especially if they are not familiar with the rules of Boolean logic. Limited functionality. Logic operators are not able to perform all the logic manipulation. It only performs the basic logic manipulation. Another complex logic manipulation requires other techniques. Now we come to some practice. For this, open IntelliJ. Here, we create a class file named logical operators. Now, we declare an integer variable named age and assigns it the value of 18. Then, uses if statement to check if the value of the variable age is greater than 18. The if statement starts with the keyword if, followed by a condition in parentheses, in this case, age greater than 18. This condition is checking if the value of age is greater than 18, using the greater than operator. If the condition is true, the code inside the curly braces will be executed. In this case, the code inside the if statement is a simple print statement that prints out condition is true to the console. If the condition is false, the code inside the if statement will not be executed, and nothing will be printed to the console. Now you can see the output here. Next, we declare another string variable named gender and assigns it the value of male. The if statement starts with the if keyword, followed by a condition in parentheses. In this case, gender equals male. The condition is checking if the value of gender is equal to male, using the equals operator. If the condition is true, the code inside the if statement will be executed. The code inside the if statement is a simple print statement that prints out condition is true. In this case, since the value of gender is male, the if statement condition is met, so the code inside the if statement will be executed, and the output will be condition is true. Now you can see the two outputs here. First for upper if statement, and second for below if statement. Now we use the AND operator to combine these two conditions into one if statement. For example, if we want to check if the age is equal to 18 and the gender is equal to male, then output is given, and that is eligible. First, we will comment these print method statements because we want only the last generated output. So we use already created variables from the above, which are age and gender. The if statement starts with the keyword if, followed by a condition in parentheses. In this case, age greater than 18, and operator gender equals double quote male. The condition is checking if the value of age is greater than 18, and if the value of gender is equal to male, using the greater than and equals operators respectively. The AND operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement is a simple print statement that prints out eligible to the console. If either of the conditions is false, the code inside the if statement will not be executed, and nothing will be printed to the console. Now you can see the output here. See another example. For this, we create a class file named logicaloperators1. Now we declares 4 integer variables, a base c and d, and initializes them with the values 10, 20, 20, and 0 respectively. The if statement starts with the keyword if, followed by a condition in parentheses. In our case, parentheses are less than b, and operator parentheses b equals c. The condition is checking if the value of a is less than b, and if the value of b is equal to c, using the less than and equals operators respectively. The and operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement assigns the sum of the variables a, b, and c to the variable d, and prints out the sum is along with the value of d. Then if statement will be executed. Because the values of a and b are 10 and 20 respectively, and b equals c, which is 20. So the result will be the sum is 50. Now you can see the output here. It's a simple example of how logical operator can be used to check multiple conditions in a single statement and perform different actions based on the outcome. It's also a good practice to initialize variables with meaningful values. This will help to improve the readability and maintainability of the code. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Keywords and expressions. In this lecture, we will discuss keywords and expressions in Java. We'll improve on expressions a little bit and discuss more about keywords, which to some level we've already explored in the previous. Starting with the keywords, now there are 51 reserved keywords in Java that are utilized as keywords in your programs, as you can see from these reserved keywords here. As you can see from the following list of Java keywords, each of the 51 reserved terms in the Java programming language has a specific meaning, like int, double, float, and so on. Don't worry, none of these are necessary to memorize since we will cover each and every one of them in the course. Java actually uses the terminology of character sequences to describe these keywords because as of Java 9, the underscore by itself is a keyword. A character sequence refers to a specific sequence of characters that have a specific meaning in the Java programming language. These character sequences are reserved by the language and cannot be used as variable, method, or class names. For example, the keyword class is a character sequence that is reserved in Java. It cannot be used as the name of a variable, method, or class, as it has a specific meaning in the language related to defining classes. In addition to reserved keywords, in JDK 17, Java has 16 contextual keywords, which are only keywords in special situations. Let's open IntelliJ and talk about keywords a bit further. For the next series of lectures, I'll create a new project called Expressions and Statements. We'll walk through the process of creating a new project one more time, and after that, the videos will just specify when a new project has been created. At the Welcome to IntelliJ IDE screen, we select New Projects. For the reasons stated previously, we'll name it Expressions and Statements in camel case. We'll select Java as the language and accept all the other defaults. Finally, we'll click the Create button, and we're in a new project. In this project, we'll create a new class. Hold main by clicking on the src folder, selecting a new class, and then giving it the name keywords. Now we have the code for the main class and the editor window, so we'll also have the main method as we've done before. The public static void main, opening parentheses, string opening and closing square brackets, args closing parentheses, and opening curly brace and closing the curly brace. And you can see from this that IntelliJ is actually highlighting keywords in blue to show us that they are a keyword. Anything in blue that's in the IntelliJ editor is confirming to you that this is a reserved word. For example, we create a variable name using any of the keywords, like double equals 2.0 semicolon. The IntelliJ is definitely trying to tell us that something is wrong with the red underscores, and if we hover over one of these red underscores, IntelliJ sends messages by the expected identifier. And that's because as far as IntelliJ is concerned, second double is a reserved word, and it's actually a data type. We could not use it as the variable name. If we change this from double to double one, the error is removed because double one is not a reserved keyword. So simply make sure you aren't using a reserved keyword, and you can refer back to that list shown before. So if you get into word errors, just make sure that you're not using a reserved keyword. There are some words that are officially keywords, but are specified. These two categories are true, false, and null. And although they are officially keywords instead of literal values, we can't use true or false or null to name any of our variables or other elements. Coding is related to writing documents. It is made up of unique hierarchical components that work as a whole. These are expression. So an expression is a combination of one or more literals, variables, operators, and method calls that can be evaluated to a single value. Expressions can be used to perform calculations, assign values to variables, and control the flow of a program. In simple words, an expression compute to a single value. Then statement. So a statement is a single instruction that tells the program to perform a specific action. In simple words, statements are standalone units of work. In code blocks, a code block is a group of statements enclosed in curly braces. Code blocks are used to define the scope of variables and to group statements together. Let's start with expression. We already discussed a little bit about expression in our previous lectures. Here we see some of its example. Let's set some code to our main method. But first we'll delete that first variable we created since we don't need it for this next example. And now let's add some more interesting code. So write double miles equals opening parentheses 70 multiply 0.621371 closing parentheses semicolon. Here we're creating an expression to convert kilometers into miles using the conversion formula. 1 kilometer is equal to 0.621371 miles. In this code, we want to figure out what 70 kilometers are converted to miles. This entire line of code is a valid statement. For that line, the actual expression is this component of the entire line. The data type does not form part of an expression, but everything else on the line typically forms or is part of the expression. So the expression component can include variables, values, and operators. All of those are used in this case. We've got variable miles and we've got values like 70, and of course operators, which in this case include the equals and multiplication symbols. So that's an expression. By including the data type and ending with a semicolon, we now creating a valid Java statement. Let's look at some more examples of expressions. So write a program that checks if the value of x is greater than 3. If the condition is true, increment the value of x by 10. So we declares a variable called x and assigns it the value of 5. Then use if statement. It checks the condition inside the parentheses, which is x greater than 3. The expression inside the parentheses is x greater than 3, which is a relational operator that checks if the value of x is greater than 3. If the condition is true, the code inside the curly braces will be executed. In this case, it is a single line of code that increments the value of x by 10. The new value of x will be 15. You can see that x equals 5 is a valid expression, but the int data type and semicolon are not part of it. But by adding these, it becomes a statement. Same as the x greater than 3 is a valid expression, and if parentheses are statements, and in the calculation, in the if statement code block, there are actually two expressions. First, the calculation by itself, 10 plus x is one expression. Second, the entire line excluding the semicolon is an expression too. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Nested if-then-else concept. In this lecture, we will discuss nested if-then-else concept. In the previous few lectures, we discussed about if-then, if-then-else, and ladder if-then-else conditional statements, and also saw some of its examples. Now we will see the concept of nested if-then, if-then-else, and ladder if-then-else. The term nested refers to the placement of one thing inside another. In the context of programming, it refers to the placement of one control flow statement, such as an if-then-else statement within another control flow statement. In other words, one control flow statement is nested inside of another. When an if statement is nested inside another if statement, it is called a nested if statement. The inner if statement is executed only if the condition of the outer if statement is true. So in Java, you can use if-then-else statements inside of other if-then-else statements to create a nested structure. This is known as a nested if-then-else. The inner if-then-else statement is executed only if the condition of the outer if-then-else statement is true. Here you can see the syntax. Here, the outer if statement has a condition 1, which is evaluated first. If condition 1 is true, then the code inside the first set of curly braces is executed. Inside of that code block, there is another if statement with a condition 2. This inner if statement is nested within the outer if statement. If condition 2 is true, then the code inside the second set of curly braces is executed. However, if condition 2 is false, the code inside the else block is executed. If the condition 1 is false, then the code inside the outer else block is executed. However, if condition 2 is false, the code inside the else block is executed. Now see an example for this. Open IntelliJ. Here we create a class file named nestedifelse and create main method. Now see an example. So in this example, we create a program to determine whether a number is both positive and even. For this, first we create a variable number is initialized with a value of 5. Then we use a nested if-then-else statement to check the value of number in that way. Use an outer if statement to check if number is greater than 0. If it is, the code inside the first set of curly braces is executed. Inside of that code block, there we write an inner if statement that checks if number is even by using the modulus operator. The modulus operator returns the remainder when one number is divided by another, so if number %2 is 0, it means the number is even. If this inner if statement's condition is true, the code inside the second set of curly braces is executed, which prints out a message saying the number is positive and even. If the inner if statement's condition is false, The code inside the inner else block is executed, which prints out a message saying the number is positive but not even. If the outer if statement's condition is false, the code inside the outer else block is executed, which prints out a message saying the number is not positive. In our example, since number is 5, the if statement number greater than 0 will be true. The inner if statement number modulus 2 equals to operator 0 will be false, and the output is 5 is positive but not even. Here is the output. There are several advantages to using nested if-then-else statements in Java, like flexibility. Nested if-then-else statements allow you to create complex control flow in your program by combining multiple conditions. This can be useful when you need to check multiple conditions before making a decision. Reusability. Nested if-then-else statements can be used to create reusable code blocks that can be used in multiple places in your program. This can save time and make it easier to maintain your code more efficient. Using nested if-then-else statements can be more efficient than using multiple independent if-then-else statements. This is because nested if-then-else statements can check multiple conditions in a single statement, whereas multiple independent if-then-else statements would require multiple conditions to be checked. Better readability. Nested if-then-else statements can make the code more readable by providing a clear structure for the control flow of the program. By using indentation and comments, it's easier to understand the purpose and flow of the code. While nested if-then-else statements can be useful in certain situations, they also have some limitations in Java, like complexity. Nested if-then-else statements can make your code more complex and harder to read, understand, and maintain. As the number of conditions and nested levels increase, it can be difficult to keep track of what is happening in the code. Error-prone. As the code becomes more complex, it can be easier to introduce errors, such as logical errors or syntax errors, which can be difficult to detect and fix. Slow performance. Nested if-then-else statements can be slower than other control flow structures, especially when the number of conditions and nested levels increase. Unnecessary nesting. It's possible that the use of nested if-then-else statements is unnecessary, and another control flow structure or function call might be more appropriate and efficient. Harder to debug. Nested if-then-else statements can make it more difficult to debug your code, especially when there are multiple levels of nesting and multiple conditions that need to be checked. Now see an example. For this, open IntelliJ. Here we create a class file named nestedifelse1 and create main method. Now see an example. So in this example, we create a program that checks if a customer has made a purchase and the store wants to offer a discount based on the purchase amount and membership status. For this, first we create two variables, purchase amount and is member. The variable purchase amount is of type int and is assigned a value of 120. It represents the amount of money the customer has spent on the purchase. The variable is member is of type string and is assigned a value of yes. It represents the membership status of the customer. Then use outer if statement checks if the purchase amount is greater than 100. If it is true, the code inside the first set of curly braces is executed. Inside of that code block, there is an inner if statement that checks if the customer is a member or not. Condition is member equals to yes. If the customer is a member, the inner if statement prints you are eligible for a 10% discount. And if the customer is not a member, the inner else statement prints you are eligible for a 5% discount. However, if the outer if statement's condition is false, the code inside the outer else block is executed, which prints you are not eligible for a discount. In our example, the purchase amount is 120 and the customer is a member. So the output is you are eligible for a 10% discount. Here you can see the output. I hope you learned something useful in this lecture as well. And I'll see you in the next one. Method overloading, exercises part 7. In the previous lectures, we practiced examples using the overloading method. We will now practice some more examples of it. Now see a little more complexity in the example. So we write a Java program that obtains the number of years, months, and days that have passed since you or someone else's birth date, and also find how old someone will be on a future date, and how old someone was at a specific date, like at marriage, death, any other important events, etc., and gets your age in other units, such as years, months, or days. Now, first we learn about formula used in calculating age. So, to calculate someone's age in years, months, and days, first find the differences between the person's birth year, month, and day with the current year, month, and day. To find the difference of year, use the formula years equals birth year minus current year. To find the difference of month, use the formula months equals birth month minus current month. And to find the difference of days, use the formula months equals birth month minus current month. Days equals birthday minus current day. Then we convert these find difference into total days using formula age in days equals parenthesis years multiplied by 365 plus parenthesis months multiplied by 31 plus days. Till here we got the difference between years, months, and days. After that, then we convert all these differences into days. Now we will again make years, month, and days of our total age. For this, we use formula to make years of our age. That is, y equals d divided by 365. This formula calculates the number of years by dividing the difference in days. That is d divided by 365. That is the number of days in a year. Now to get the remaining month from years, we use formula that is m equals parenthesis d minus y multiplied by 365 divided by 30. This formula calculates the number of months by subtracting the number of years, that is y, from the difference in days, that is d, and then dividing the result by 30. That is the number of days in a month. Now, to get the remaining days from month, we use formula that is d equals parenthesis d minus y multiplied by 365 minus m multiplied by 30. This formula calculates the number of days by subtracting the number of year, that is y, and months, that is m, from the difference in days, that is d. I think now you understand the formula that calculates age. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named age and create a main method inside this class. Now we will implement method overloading. So our program should use 3 overloaded methods with name find age. First method calculate the difference between birth date and current, and after that convert all into days. Then the second method, in this method we will get days value from first method, and then that difference of days value will be converted into years, month, and days again. Then the third method checks. If value is negative, then it changes it into positive value by multiplying with -1. So now we create our first method using public static int, then its name, find age. This method takes in 6 parameters that are int birth year, int current year, int birth month, int current month, int birth day, and int current day. Inside the method, we use this formula, that is, int years equals birth year minus current year, semicolon. This line calculates the difference in years between the birth year and the current year and assigns the result to the variable years. Then write int months equals birth month minus current month, semicolon. This line calculates the difference in months between the birth month and the current month. After that, assigns the result to the variable months. Then write int days equals birthday minus current day, semicolon. This line calculates the difference in days between the birthday and the current day and assigns the result to the variable days. Then use int age in days equals parenthesis years multiplied by 365 plus parenthesis months multiplied by 31 plus days, semicolon. This line calculates the total number of days by multiplying the number of years by 365, that is, the number of days in a year, and multiplying the number of months by 31, that is, the number of days in a month, and adding the number of days. The result is assigned to the variable age in days. Here you can see that until ij given the error, because we did not create find age yet. Then write return age in days, semicolon. This line returns the value of age in days. Now we create second method using public static int, then its name, find age. This method takes in 4 parameters that are int age value, int y, int m, and char ch. Here age value, which is the total number of days, the variable y, which represents the number of years, the variable m, which represents the number of months, the variable ch, which is a character that indicates the value, that is y for years, n for months, or d for days. Inside the method body, we use if and later if-else statements. So this if-else statement calculates the age in either years, months, or days based on the value of ch. If ch is single quote y, the age is calculated as age value divided by 365, which gives the total number of years, and again stored into age value. If ch is single quote m, the age is calculated as parenthesis age value minus y multiplied by 365 divided by 30, which gives the total number of months, and again stored into age value. If none of 2 conditions are true, then use else age value minus y multiplied by 365 minus m multiplied by 30, which gives the total number of days, and again store into age value. Remember that this method converts total days, returned by first method to actual age into years, month, and days. Then it returns the age value. Now we create third method using public static int, then its name, find age. This method takes in 1 parameter, that is int check negative. This method takes an integer value, check negative, as its parameter. Then inside the body, it checks if the value of check negative is less than 0. Then it multiplies it with -1. This is done to make sure that the value of check negative is positive. as the age cannot be negative. Finally, the method returns the absolute value of check negative as the result. Now we call these methods in the main method. For this, we have variable total days is created and assign the result of calling the findAge method with the parameters parentheses 1994, 2023, 7, 11, 24, 11, representing the birth year, birth month, current month, birthday, and current day, respectively. Then another variable getYears is created and assign the result of calling the findAge method with parameters parentheses total days, 0, 0, single quote y. Here total days variable is the total days calculated by first method, and 0.0 means we only convert these days of age into years and y value true, the first condition of this method. Then this method returns the number of years in the total number of days. Then another variable getMonth is created and assigned the result of calling the findAge method with parameters parentheses total days, getYears, 0, single quote m. Here total days variable is the total days calculated by first method, and getYears is the years calculated by second method. First if statement, and m means the second else if statement, became true and calculate the month of age. Then this method returns the number of months in the total number of days after subtracting the number of years. Then another variable getDays is created and assign the result of calling the findAge method with parameters parentheses total days, getYears, getMonth, single quote d. Here total days variable is the total days calculated by first method, and getYears is the years calculated by second method of first if statement, and getMonth is the months calculated by second method of second else if statement, and d means no if statement become true and the else became true, so it calculates the days of age. Then this method returns the number of days in the total number of days after subtracting the number of years and months. Then the values of getYears, getMonth, and getDays are printed to the console using the println method. Now run it. Here you can see the output, that is 29 years, 3 months, 21 days. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Switch statement. In this lecture, we will discuss about switch statement in Java. We already learned about if then else, ladder if then else, and nested if then else conditions in detail, and also practiced some of their exercises in our previous lectures. I think you should now have a better idea of how to control the flow of a Java program. Now we come forward and discuss another important control statement, which is the switch statement, as I said earlier. So the switch statement in Java is used as a control structure to execute one of several branches of code based on the value of an expression. It provides a way to handle multiple cases or conditions in a more efficient and readable way compared to using a series of if-else statements. The switch statement has gone through many enhancements since Java 8, but we'll be looking at the traditional switch statement to start. Now we see that the syntax for the switch statement, we start with the keyword switch. That's followed by the value we want to check in parentheses, followed by the opening curly brace, which starts to switch code blocks. And then there's the closing curly brace. Within the curly braces, there are some new keywords we haven't seen before: case, break, and default. The case keyword is used with the switch statement for comparison. The switch value case essentially means in the case that value equals A, execute this code. If it doesn't, then move on to check the next case. The break keyword tells us which statement to terminate any further checks. The break statement is optional in switch and we'll talk about it more shortly. So here the default keyword indicates that this code should be executed if none of the preceding conditions are met. Now we will see the comparison of switch and if-then-else statements. So the if-then-else statement and the switch statement are both used to control the flow of execution in a Java program, but there are some key differences between the two, like the expression type. The expression in an if-else statement can be of any type, including integer, float, double, or even an object, while the expression in a switch statement must be of a primitive data type, such as int, char, or short, or a wrapper class, such as integer, character, or short. Multiple conditions. With an if-else statement, you can write multiple conditions to handle different cases, while with a switch statement, you can handle multiple cases but only one expression is evaluated and compared to each of the case values. Readability. The switch statement can be more readable when handling multiple cases compared to a series of if-else statements, especially when dealing with a large number of cases. Performance. The performance of the switch statement is generally faster than an if-else statement, especially when dealing with a large number of cases. There are several advantages of using the switch statement in Java over the traditional if-else statement, like readability. Switch statements can make code more readable, especially when dealing with a large number of conditions. By grouping the conditions together in a clear and concise way, cleaner code, switch statements can help to make code more organized and easier to maintain by separating the conditions and their associated code blocks into distinct sections. Easy to use. The switch statement is easy to use and requires less typing compared to if-else statements, better handling of multiple cases. The switch statement is especially useful when dealing with multiple cases, as it provides a simple and readable way to handle each case without the need for nested if-else statements. Better type safety. The switch statement only allows for certain data types as expressions, whereas if-else statements can accept any expression, which can lead to type mismatch errors. Better error handling. The switch statement provides the default case, which can be used to handle unexpected cases, providing a way to catch potential errors. Overall, the switch statement can greatly improve the readability, performance, and maintainability of your code, and it is especially useful when dealing with multiple cases. While the switch statement has several advantages, it also has some limitations like limited data types. The switch statement only supports a limited number of data types as expressions, including byte, short, int, and char values. If you need to use a different data type, you will need to use a if-else statement instead. No range checks. The switch statement does not allow for range checks, which can be performed using if-else statements. If you need to check whether a value is within a certain range, you will need to use a if-else statement instead. No use of expressions. The switch statement does not allow for expressions to be used as cases, only constant values. This can limit its flexibility when compared to if-else statements, which can accept any expression. No support for null values. The switch statement does not support null values as expressions, which can cause issues if you need to handle null values in your code. Unpredictable behavior. The switch statement can have unpredictable behavior if a break statement is omitted from the end of a case block, causing execution to fall through to the next case. This can be a source of bugs and should be avoided. No short-circuit evaluation. The switch statement does not provide short-circuit evaluation, meaning that all cases are evaluated even if a match is found. This can lead to a decrease in performance, especially when dealing with a large number of cases. I think now you understand basic syntax and also understand the compression between switch and if-then-else statements. I hope you learned something useful in this lecture as well, and I'll see you in the next one. For loop exercise, in this lecture we will practice some of examples using for loop. For this, we write a program that have a method named checkodd that takes an integer as input and returns a Boolean value, indicating whether the number is odd. It first checks if the number is less than or equal to 0. If it is, it returns false. If it is, the number is odd, and the method returns true. Otherwise, the method returns false. Then program have another method named addSumNumbers that takes two integers as input, start number and end number, which represent a range of numbers. It first checks if the input is valid by checking if both start number and end number variables are greater than 0, and if end number variable is greater than or equal to start number variable. If the input is not valid, the method returns -1. Otherwise, it initializes a variable sum to 0 and iterates through the range of numbers from start number to end number. For each number in the range, it calls the addSumNumbers method to check if the number is odd. If it is, it adds the number to sum. After iterating through all the numbers in the range, the method returns sum. In simple words, this program will add only odd numbers in a given range. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named SumOddNumber. Then create a main method inside this SumOddNumber class by writing shortcut PSVM. Now we create first custom method by writing public static boolean checkodd open parentheses, int number close parentheses curly brace. So here we define a method called checkodd that takes an integer parameter number and returns a Boolean value. Then we write inside this method, if open parentheses number less than equals to 0, close parentheses, curly braces. Then inside this if statement, write return false semicolon. If statement checks if number is less than or equal to 0. If number is less than or equal to 0, the method returns false, indicating that the number is not odd. This check is necessary because, by definition, an odd number is a positive integer that cannot be divided by 2 without a remainder. If number is less than or equal to 0, it cannot be an odd number, and the method returns false to indicate this. If number is greater than 0, the method does not immediately return a value. Instead, the method continues to execute any code that follows the if statement, which in this case is the end of the method. This means that the method does not actually check whether number is odd or not. To check whether number is odd or not, we add this code after the if statement closing curly brace. So we write return open parentheses number %2 equals 1, close parentheses semicolon. This statement checks whether the remainder of dividing number by 2 is equal to 1. If the remainder is 1, then number is odd, since an odd number cannot be divided by 2 without a remainder. If the remainder is 0, then number is even, since an even number can be divided by 2 without a remainder. The modulus operator % in Java returns the remainder of dividing the first operand, the second operand. In this case, the first operand is number and the second operand is 2. If number is odd, then the remainder of dividing it by 2 will be 1. And the expression parentheses number %2 equals 1 will evaluate to true. If number is even, then the remainder of dividing it by 2 will be 0, and the expression will evaluate to false. Now we create second custom method by writing public static int sum odd open parentheses, int start number comma int end number close parentheses curly braces. Here we define a method called SumOdd that takes two integer parameters start number and end number and returns an integer value. This method is used to calculate the sum of all odd numbers between start number and end number inclusive. Then inside this method we write if open parentheses start number less than equals to 0 or end number less than equals to 0 or end number less than start number, close parentheses curly braces. Then inside if statement write return -1 semicolon. So inside the parentheses of if statement it checks if any of the three specified conditions are true. Each of these conditions checks a specific aspect of the input parameters start number and end number. First, start number less than equal to 0. This condition checks if the value of start number is less than or equal to 0. If this condition is true, it means that the value of start number is either negative or 0, which is not a valid input for the SumOdd method. Then end number less than equal to 0. This condition checks if the value of end number is less than or equal to 0. If this condition is true, it means that the value of end number is either negative or 0, which is also not a valid input for the SumOdd method. Then end number less than start number. This condition checks if the value of end number is less than the value of start number. If this condition is true, it means that the range of numbers specified by start number and end number is invalid, because end number is less than start number. If any of the three conditions are true, the SumOdd method immediately returns -1, indicating that the input is invalid. If all three conditions are false, the method continues to next. So then we write int sum equals 0 semicolon. Here we initialize our variable sum to 0. This variable will be used to store the sum of all odd numbers in the range of numbers specified by start number and end number. Then we write for open parentheses int I equals start number semicolon, I less than equal to end number semicolon, I plus plus close parentheses curly braces. Here the for loop iterates all the integers in the range specified by start number and end number, including both start number and end number. So the first part of loop is int I equals start number. This is the initialization statement which creates a new variable I and initializes it to the value of start number. This statement is executed only once before the loop starts iterating. Then I less than equal to end number. This condition checks whether the value of the loop variable I is less than or equal to the value of the end number parameter. If the condition is true, the loop continues to iterate. If the condition is false, the loop terminates and control is passed to the next statement after the loop. So in the SumOdd method, the loop iterates over all the integers between start number and end number inclusive. The condition I less than equal to end number ensures that the loop terminates once I reaches the value of end number. This ensures that the loop does not continue iterating indefinitely, and that the sum of all odd numbers in the range is correctly calculated. Then inside the loop body we write if open parentheses check odd, open parentheses I, double close parentheses, curly braces, sum plus equals I semicolon. The check odd is a method call that checks whether the integer value of I is odd or not. If I is odd, the method returns true. If I is even, the method returns false. The if statement checks the return value of the check odd method for the current value of I. If check odd method returns true, the code inside the curly braces increments the sum variable by the value of I. This statement adds the current value of I to the running total of odd numbers in the range from start number to end number. If checkodd method returns false, the code inside the curly braces is skipped and the loop proceeds to the next iteration with the next value of I. This ensures that only the odd numbers in the range are added to the sum variable, and the sum of all odd numbers in the range is correctly calculated. Then outside of the loop body, write return sum semicolon. Finally, the SumOdd method returns the value of sum, which should be the sum of all odd numbers between start number and end number. Now we go inside the main method to call these two methods to calculate and print the sum of odd number. For this we write int start number equals 1 semicolon, int end number equals 100 semicolon, int sum equals SumOdd open parentheses, start number comma end number close parentheses semicolon. Here the integer variables, start number and end number, are initialized to the values 1 and 100 respectively. Remember that these variables are local variables and cannot affect each other because of their same name. These variables define the range of integers over which the SumOdd method will sum all odd numbers. The SumOdd method is called with the parameters start number and end number. The method calculates the sum of all odd numbers in the range from start number to end number inclusive. The sum of all odd numbers in the range is assigned to the integer variable sum. Then write if open parentheses sum equals minus 1, close parentheses curly braces, system.out.println open parentheses double quote, invalid input close parentheses semicolon. Here the if statement checks whether the sum variable is equal to minus 1. The SumOdd method returns minus 1 if either start number or end number is less than or equal to 0, or if end number is less than start number. If sum variable is equal to minus 1, the program prints invalid input to the console. Then we write else curly braces, system.out.println open parentheses double quote, the sum of odd numbers between plus start number plus double quote and plus end number plus double quote is plus sum close parentheses semicolon. Here this else block is executed when the if condition in the previous line evaluates to false. In other words, if the sum of all odd numbers in the range is not equal to minus 1, then the program proceeds to the else block. In this code, the system.out.println method prints a message to the console that indicates the sum of all odd numbers in the range. The message is composed of several strings concatenated with the plus operator. The first string is the sum of odd numbers between, which is a literal string that is always printed. The second and third strings are the values of start number and end number respectively. The fourth string is word, which is a literal string that separates the range from the sum. The fifth string is the value of sum, which is the sum of all odd numbers in the range. Now we run it. Here you can see the output after a successful run, which is the sum of odd numbers between 1 and 100 is 25. Let's look at its summary. This program contains three methods: checkodd, SumOdd, and main. Checkodd takes an integer as input and checks whether it is odd or not and returns a boolean. SumOdd takes two integers as input, start number and end number, and calculates the sum of all odd numbers within that range, inclusive of the end number, using a for loop calling the checkodd method for each number. If the inputs are invalid, either start number or end number is less than or equal to 0, or end number is less than start number, it returns minus 1. The main method initializes the start number and end number variables, calls the SumOdd method, and prints out the result or an error message if the inputs are invalid. Now we see another example. So we write a program that will amaze you with its ability to print any multiplication table you desire. With the power of the for loop, you can watch as each number in the table is printed in sequence, building up the full table right in front of your very eyes. Whether it's the 2 times table or the 5 times table, or any other table you can think of. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named mathTable. Then create a main method inside this mathTable class by writing shortcut PSVM. Now first we write inside the main method int num equals 5 semicolon. Here we initialize our variable num with the value 5. The int keyword specifies that num is an integer data type, which means it can only hold whole numbers. Then write for open parentheses int I equals 1 semicolon, I less than equals to 10 semicolon, I plus plus close parentheses curly braces. Here we use for loop statement. It consists of 3 parts, separated by semicolons. Initialization, int I equals 1. In this part, we declare and initialize a loop variable I with an initial value of 1. This variable will be used to iterate through the loop. Condition I less than equals to 10. In this part, we specify the condition that must be true for the loop to continue running. In this case, the loop will continue running as long as the value of I is less than or equal to 10. Once the value of I becomes greater than 10, the loop will stop running, and the program will move on to the next statement after the loop. Iteration I++. In this part, we specify an expression that is executed at the end of each iteration of the loop. In this case, we increment the loop variable I by 1. Then inside the loop, we write system.out.println open parentheses num plus double quote multiply sign plus I plus double quote equals plus open parentheses num multiply I double close parentheses semicolon. Here system.out.println statement is a statement in Java used to print output to the console. Num is the value of the number whose table is being printed, which in this case is 5. I is the value of the current iteration of the loop, which ranges from 1 to 10. Double quote X is a string literal that is used to represent the multiplication symbol. Parentheses num multiply I is the product of num and I, which represents the result of the multiplication. Now we run it. Here you can see the output after a successful run, which is the table of 5 from 1 to 10. So the entire for loop iterates 10 times, each time printing the current iteration number, the multiplication sign, the value of I, the equals sign, and the product of num and I. I hope you learned something useful in this lecture as well, and I'll see you in the next one. While statements. In this lecture, we will discuss about while statement in Java. So the while loop, that might seem simpler because it will just continue to execute code until its loop expression becomes false. So the while loop is used when we don't know how many times we need to execute a block of code. It continues to execute until the condition becomes false. So the initiation is made before the while loop. Then while loop statement and inside the parenthesis use condition that the loop will execute repeatedly as long as the condition is true. The code within the loop will execute repeatedly until the condition is false. The increment or decrement of the loop is done within the loop. Now start with a simpler example using for loop. So we write a program to print numbers from 10 to 1 using a while loop. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named while loop. Then create a main method inside this while loop class by writing shortcut PSVM. In the main method we write int number equals 10 semicolon. Here we are declaring a new variable named number of type int and initializing it with the value 10. This means that number is assigned the value 10 at the start of the program. and this value will be used as the starting point for the loop. As the loop executes, the value of number will be decremented by 1 until it reaches 1, and each value of number will be printed to the console. Then write while open parentheses number greater than equals to 1, close parenthesis curly braces. In this statement, we are defining a while loop that will execute the code inside the curly braces repeatedly as long as the condition number greater than equals to 1 is true. The condition number greater than equals to be a Boolean expression that is evaluated at the beginning of each iteration of the loop. If the condition is true, the code inside the curly braces is executed. If the condition is false, the loop is exited, and execution continues with the next statement after the while loop. In this case, the condition greater than equals to means that the loop will continue to execute as long as the value of number is greater than or equal to 1. The loop will exit when the value of number becomes less than 1. Then write system.out.println parentheses number semicolon, number minus minus semicolon. Inside the loop, we first print the value of number to the console using the println method. Then we decrement the value of number by 1 using the number minus minus statement. The loop will continue to execute as long as the value of number is greater than or equal to 1. On each iteration, the value of number will be printed to the console, starting from the initial value of number and counting down by 1 on each iteration. The loop will exit when the value of number becomes less than 1. Now run this. Here is the output after successfully running, which is a number from 10 to 1. So when we run this program, first at the beginning of the loop, number variable is initialized to 10. Then loop condition, number greater than equals to 1, is evaluated and found to be true because number is currently equal to 10. Println statement prints the value of number, which is 10 to the console. Then decrements the value of number by 1, so it now has a value of 9. Then condition is evaluated again and found to be true because number is still greater than or equal to 1 and prints the value of number, which is 9 to the console, and decrements the value of number by 1, so it now has a value of 8. Steps repeat until number has a value of 1. And its printed number variable values 8, 7, 6, 5, 4, 3, and 2. Now it's became 1. So it now prints the value of number, which is now 1 to the console. Then decrements the value of number by 1, so now it has a value of 0. Then condition is evaluated again and found to be false because number is now less than 1, which terminates the while loop. Now we change the while condition from number greater than or equal to 1 to a Boolean value that is true. If we run it at this movement, the loop runs infinitely because the loop condition is always true and prints numbers from 10 to minus infinite value, and it creates an exception as you can see. Now stop it by pressing stop button in Intel IJ. So to handle this, we use an if statement and check if the value of the number is less than 1, at which point the loop will immediately terminate. For this we write if open parentheses number less than 1, close parentheses curly braces break semicolon. Here the if statement checks if the value of the number variable is less than 1. If this condition evaluates to true, the break statement is executed. Break statement is a control statement that is used to terminate the enclosing loop, or switch statement immediately. In this case, if the value of number is less than 1, the break statement will cause the while loop to terminate immediately. Now run this. Here is the output after successfully running, which is same as previous. Now we see another example. So we write a program to find even and odd numbers within a given range, using a custom method check even odd. Now let's start creating this program. Now we create another class file named while loop1. Then create a main method inside this while loop1 class by writing shortcut psvm. Now we create a method first. For this we write public static void check even odd, open parentheses int num, close parentheses curly braces. Here the check even odd method takes an integer argument num and will check whether it is even or odd. Then we write if open parentheses num modulus 2 equals 0, close parentheses curly braces, system.out.println open parentheses num plus double quote is even, close parentheses semicolon. Then write else curly braces system.out.println open parentheses num plus double quote is odd, close parentheses semicolon. First we use if statement, and inside it we use condition, that is a Boolean expression that checks whether a given number num is even or odd. So the modulus operator calculates the remainder of num divided by 2. If the remainder is 0, then num is evenly divisible by 2, which means that num is an even number. Therefore, if num modulus 2 is equal to 0, then the entire expression num modulus 2 equals 0 evaluates to true, which means that num is even, and inside it we print the message num is even. If num modulus 2 is not equal to 0, then the entire expression num modulus 2 equals 0 evaluates to false, which means that num is odd, and inside it we print the message num is odd. Now go into main method to call this method and find even and odd numbers. So first we write int start equals 5, and equals 11 semicolon. Here we declare two integer variables named start and end, and initialize them to 5 and 11 respectively. And the purpose of these variables is to set our range. Then write while open parentheses start lesser than or equal to end, close parentheses curly braces. Check even odd, open parentheses, start semicolon, start plus semicolon. Here we use while loop, and inside it we use the condition. Start less than equals to end is a Boolean expression that evaluates to true if the value of the variable start is less than or equal to the value of the variable end, and false otherwise. During each iteration of the loop, the condition start less than equals to end is checked. If the condition is true, the code inside the curly braces is executed. So check even odd is a method call that passes the current value of start as an argument to the check even odd method. This method determines whether the number is even or odd and prints a message to the console indicating which it is. Then start plus is a shorthand notation for start equals start plus 1, which increments the value of start by 1 on each iteration of the loop. Now run it. Here is the output after successfully run. Here 6, 8, 10 are even numbers, and 5, 7, 9, 11 are odd numbers. Now we see another example. So write a program which creates a method named sum of digits with one parameter of type int called number. The method needs to find the first and the last digit of the parameter number passed to the method using a loop, and return the sum of the first and the last digit of that number. If the number is negative, then the method needs to return -1 to indicate an invalid value. Now let's start creating this program. For this, we create another class file named while loop2. Then create a main method inside this while loop2 class by writing shortcut psvm. Now we create a custom method by writing public static int sum of digits, open parentheses int number, close parentheses curly braces. Then inside it we write If open parentheses number less than 0, close parentheses curly braces, return -1 semicolon. So the sum of digits method takes an integer parameter number and will return the sum of the first and the last digit of that number. If the number is negative, it returns -1 to indicate an invalid value. This check for negative numbers is done using an if statement with a condition number less than 0. If the condition is true, the method immediately returns -1, indicating that the input number is invalid. This is important because the calculation of the first and last digits is only possible for non-negative numbers. Then we write int last digit equals number modulus 10 semicolon. Int first digit equals number semicolon. After checking for negative numbers, the method first calculates the last digit of the input number using the modulus operator. This is done by taking the input number and computing its remainder when divided by 10. For example, if the input number is 1, 2, 3, 4, then the last digit will be 4. Next, the method calculates the first digit of the input number. For this, the first digit is initialized to number variable. Then we write, while open parentheses, first digit greater than equals to 10. Close parentheses curly braces, first digit divided by equals 10 semicolon. Here a while loop is used to repeatedly divide it by 10 until it becomes less than 10. At each iteration, the result of the division is assigned back to first digit. For example, if the input number is 1, 2, 3, 4, the while loop will divide it by 10 3 times, resulting in first digit being assigned the value 1. Then write return first digit plus last digit semicolon. Finally, the method returns the sum of the first and the last digit, which is computed by adding the values of first digit and last digit. For example, if the input number is 1, 2, 3, 4, the sum of the first and last digit will be 1 plus 4 equals 5. Now go into main method to call this method and find sum of first and last digit. For this, first we write int number equals 1, 2, 3, 4, 5, 6 semicolon. Int sum equals open parentheses, sum of digits number close parentheses semicolon. Here we create an integer variable number and assigns it the value 1, 2, 3, 4, 5, 6, and then calls the sum of digits method with number as the argument and assigns the returned value to an integer variable sum. Then we write system.out.println open parentheses double quote. Sum of first and last digit of plus number plus double quote is plus sum open parentheses semicolon. Here we use the println method to print a message to the console. Here sum of first and last digit is a string literal that describes the purpose of the message, and number is a variable that contains the number for which the sum of first and last digit is computed. Colon is another string literal that separates the message from the computed sum, and sum is a variable that contains the computed sum of the first and last digits of the number. Here the plus operator is used to concatenate these different parts into a single string. Then we write number equals -1, 2, 3 semicolon. Sum equals open parentheses, sum of digits number close parentheses semicolon. Write system.out.println open parentheses double quote. Sum of first and last digit of plus number plus double quote is plus sum open parentheses semicolon. Here we assign -123 to number and repeats the same process, calling the sum of digits method and printing the computed sum to the console. But this time we use a negative value. Now run this. Here is the output after successfully running, which is sum of first and last digit of 1, 2, 3, 4, 5, 6 is 7. Sum of first and last digit of -1, 2, 3 is -1. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Do-while statement. In this lecture, we will discuss about do-while statement in Java. The while loop is like the while loop, except that it will always execute the code once, regardless of whether the loop condition is true or false, and then continue looping until that expression is false. The do-while loop in Java is commonly used in situations where you need to execute a code block at least once, and then continue to execute it as long as a certain condition is true. Some common use cases for do-while loops include reading user input. When reading user input, you may want to ensure that the user enters valid data before continuing. A do-while loop can be used to repeatedly prompt the user for input until valid input is provided. File or database processing. When reading data from a file or database, a do-while loop can be used to read each record until the end of the file or database is reached. The code block would contain the code to read each record, and the loop condition would check whether there are more records to read. Performing calculations. A do-while loop can be used to perform calculations until a certain condition is met, such as reaching a certain value or achieving a certain level of accuracy. Iterating through collections. When iterating through collections, you may want to execute a block of code for each element in the collection. A do-while loop can be used to ensure that the code is executed at least once, even if the collection is empty. Implementing game logic. In game development, a do-while loop can be used to implement game logic that repeats until a certain condition is met, such as the player completing a level or achieving a certain score. Now start with a simpler example using do-while loop. For this, open IntelliJ. Here we create a class file named while loop5. Then create a main method inside this while loop5 class. I write shortcut psvm. In the main method, we write int I equals 6 semicolon. Here we declare a variable named I of type int and initialize it with the value 6. The purpose of declaring I as a variable is to use it in the do-while loop. Now we write keyword do then curly braces, and inside this curly braces, we write system.out.println parentheses I semicolon, I plus plus semicolon. Then outside of the close curly brace, we write while open parentheses I less than 5, close parentheses semicolon. The loop starts with the do keyword, which indicates the beginning of the loop. The code inside the loop will be executed at least once, regardless of the condition specified in the while statement. The code inside the loop consists of two statements. Print method. This statement prints the current value of the variable I to the console. I++. This statement increments the value of the variable I by 1. Then condition in the while statement is I less than 5, which is false when I is equal to or greater than 5. This means that the loop will continue to execute as long as I is less than 5. However, since the initial value of I is 6, the loop condition is already false. So the loop will execute at once and only 6 printed to the console. Now run it. Here is the output after successfully run, that is 6. Now we will see another example. So we write a program calculates the sum of integers from a given range using a do-while loop. Now start creating program. For this, we create a class file named while loop6. Then create a main method. Inside this while loop6 class, I write shortcut psvm. In the main method, we write int x equals 21, sum equals 0 semicolon. Here we initializes two variables, x and sum. So x is being initialized to the value 21 and sum is being initialized to the value 0. This means that x will be used as the starting point for the summation loop, and sum will be used to accumulate the total sum of values. Then we write do curly braces sum plus equals x semicolon, x minus minus semicolon. Then write outside the curly braces, while open parentheses, x greater than 10 close parentheses. Here we use do keyword to start the do while loop. Inside the curly braces, the statement sum plus equals x adds the current value of x to the sum variable. The statement x minus minus decrements the value of x by 1. This means that the next time the loop executes, it will add the new value of x to sum. The loop condition x greater than 10 is evaluated at the end of each loop iteration. If the condition is true, the loop continues executing. If the condition is false, the loop exits. So the loop continues to execute as long as x is greater than 10. Since x is initially set to 21, the loop will execute 11 times, once for each value of x from 21 down to 11. During each iteration of the loop, the value of x decreases by 1, and the current value of x are added to sum. When x becomes 10 or less, the loop condition x greater than 10 is no longer true, and the loop exits. At this point, the program has calculated the sum of integers from 21 down to 11, which is stored in the sum variable. Then we write below the while system.out.println, open parentheses, double quote, summation colon plus sum, close parentheses semicolon. The line of output includes a string literal summation colon and the value of the sum variable concatenated together using the plus operator. This is called string concatenation, and it combines the two values into a single string that is printed to the console. So the output of this line of code will be a message that includes the string summation colon followed by the value of the sum variable. Now we run it. Here is the output after successfully run, that is summation 176. Now we review this program. So first initializes two variables, x with a value of 21 and sum with a value of 0. The code then enters a do while loop. The body of the loop first adds the current value of x to sum, and then decrements x by 1. This process continues as long as the value of x is greater than 10. So the loop will execute 11 times, from x equals 21 to x equals 10. And in each iteration, the value of x is added to the variable sum. Thus, the final value of sum will be the sum of all integers, from 21 down to 11 inclusive. The result of the program is outputted using system.out.println, which prints the string summation, followed by the value of sum. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Scanner. In this lecture, we will talk about Introduction to Scanner. So, the Scanner class is a class in Java's standard library that allows for reading user input or other types of input such as files or strings. It provides methods for parsing and interpreting different types of input, including integers, floating point numbers, characters, and strings. The Scanner class can be used to read input from various sources, such as the console or a file. It can be instantiated with various constructor methods, depending on the source of input. Once instantiated, the Scanner class provides various methods for reading input. So there are some of the commonly used methods of the Scanner class in Java, like next parentheses. This method reads the next token from the input stream as a string and returns it. The token is delimited by whitespace by default. Next in parentheses. This method reads the next token from the input stream as an int and returns it. It throws an exception if the next token cannot be parsed as an integer. Next line parentheses. This method reads the next line of input from the input stream as a string and returns it. It reads until it encounters a new line character, or end of input, as next parentheses. This method returns true. If there is another token available in the input stream, it returns false otherwise. Use delimiter parentheses. This method sets the delimiter pattern for the scanner. The default delimiter pattern is whitespace, as next in parentheses. This method returns true. If the next token in the input stream can be parsed as an int, it returns false otherwise. Next double parentheses. This method reads the next token from the input stream as a double and returns it. It throws an exception if the next token cannot be parsed as a double. Next boolean parentheses returns the next token from the input stream as a boolean. Next byte parentheses returns the next token from the input stream as a byte. Next short parentheses returns the next token from the input stream as a short. Next long parentheses returns the next token from the input stream as a long. Close parentheses closes the scanner and releases any system resources associated with it. So the scanner class is described as a simple text scanner which can pass primitive types and strings. To use the scanner class, we have to create an instance of scanner. You remember this means we're creating an object of type scanner. We'll use the keyword new to do it. The new keyword is used in what Java calls a class instance creation expression. In its simplest form, it's the word new, followed by the class name and empty parentheses. And often in many cases, we can pass parameters in the parentheses as we saw with methods. And we saw that we could do this with the string class passing the text in the parentheses. For reading input from the console or terminal, we instantiate a scanner object using new followed by the scanner class name and passing in system.in in the parentheses. For reading input from a file, we instantiate a scanner object using new, again with the scanner class name, but pass in a file object in the parentheses. Follows another class provided by Java for reading and writing files. We'll talk about file input later. We haven't talked about the import statement yet, but this statement lets us use classes from other people's code. In this case, Java provides a library of code, which includes the scanner class in a library called Java.UDL. Go back when we configured IntelliJ with a number of different settings. I recommend that you enable these two options. In the Auto Import menu, add an ambiguous imports on the fly and optimize imports on the family. If you enable these options, then IntelliJ will automatically add and will remove import statements as required. Now we see an example. For this, write a Java program that takes user input for their name and age and then displays their name. The program should prompt the user to enter their name and age, read the input using a scanner object, and then print out the user's name. Specifically, the program should do create a scanner object to read input from the user, prompt the user to enter their name, read the user's name input from the command line, using the next line method of the scanner object, print out the user's name, using system.out.println, close the scanner object to release any system resources associated with it. Let's start to create this program. For this, open IntelliJ, and then create a class file named scanner example, and inside this class, create a main method using shortcut psvm. First, we need to use the scanner class, so we need to import it at the beginning of our Java program using the import statement like import java.udl.scanner semicolon. Now inside the main method, we write scanner. Scanner equals new scanner. Open parentheses, system dot. in close parentheses, semicolon. Here we create a new scanner object named scanner, that is associated with the standard input stream, that is the command line. The system.in argument passed to the scanner indicates that we want to read input from the command line. Here, scanner is the name of the class we are using to read input. This scanner is the name of the scanner object we are creating. You can name it anything you like. New is used to create a new object. Scanner system.in. This call creates the new scanner object. The system.in argument tells the scanner object to read input from the command line. Then we write system.out.print, open parentheses, double quote, enter your name, close parentheses, semicolon, string name equals scanner, dot next line, parentheses, semicolon. Here println method is used to display a message to the user. It doesn't add a new line after the message, so any subsequent output will be displayed on the same line. Enter your name. This is the message that is displayed to the user. It prompts them to enter their name, string name. This declares a new variable named name that will store the user's name input. Scanner.nextLine. This method reads a line of input from the user using the scanner object named scanner. It waits for the user to enter input and press the enter key. The input is returned as a string object. After these lines of code execute, the name variable will contain the user's name input, which we can then use in our program as needed. Then we write system.out.print, open parentheses, double quote, enter your age, close parentheses, semicolon, int age equals scanner, dot next int, parentheses, semicolon. Here print method displays a message to the user, asking them to enter their age. The message is displayed on the console, or wherever the output stream of the program is directed to. Then the nextInt method of the scanner object to read an integer input from the user. The input is read as an int value and is stored in the age variable. Then we write system.out.println, open parentheses, double quote. Your name is plus name, plus double quote, and you are, plus age, plus double quote, years old, close parentheses, semicolon. Here print method is used to display a message to the user. It adds a new line after the message, so any subsequent output will be displayed on a new line. Your name is. This is the first part of the message that is displayed to the user. It tells them that we are going to display their name. Name. This part of the message includes the user's name. The plus operator is used to concatenate the string literal your name is with the value of the name variable. The result is a new string that includes the user's name, and you are. This is the second part of the message that is displayed to the user. It tells them that we are going to display their age plus years old. This part of the message includes the user's age. The plus operator is used to concatenate the string literal, and you are with the value of the age variable, and then concatenate the resulting string with that string literal years old. The final result is a new string that includes the user's age. Then finally write scanner, dot close parentheses, semicolon. This line of code calls the close method on the scanner object named scanner. This is used to release any resources that the scanner object is using, such as file handles or network connections. It's generally a good practice to close any resources that your program opens or uses to prevent memory leaks and ensure that resources are released in a timely manner. In this case, closing the scanner object isn't strictly necessary, Since we're only reading input from the console, and the scanner object isn't holding any significant resources. However, it's still a good practice to close it. Now run it. First display message that enter your name. Now we write John and press enter. After that, it displays another message. That is, enter your age. Now we write 31 and press enter. Finally, it displays that your name is John and you are 31 years old. Now see another example. So write a program that have a method named shared digit with two parameters of type int. Each number should be within the range of 10 inclusive to 99 inclusive. If one of the numbers is not within the range, the method should return false. The method should return true if there is a digit that appears in both numbers, such as 2 and 12 and 23. Otherwise, the method should return false. Let's start to create this program. For this, we create another class file named scanner example1. Now, first we need to use the scanner class. So we need to import it at the beginning of our Java program using the import statement like import java.util.scanner semicolon. Now we create a custom static method by writing public static boolean shared digit, open parentheses int num1, comma int num2, close parentheses curly braces. Here we create shared digit that takes two integer parameters num1 and num2. The method is defined with the public static modifiers, which means it can be accessed from outside the class and can be called without creating an instance of the class. The method returns a boolean value of true or false. Then inside this method, we write if double open parentheses num1 less than 10 or num1 greater than 99, close parentheses or open parentheses, num2 less than 10 or num2 greater than 99, double close parentheses, curly braces, return false semicolon. Here inside the method, we use if statement that checks whether num1 and num2 are within the range of 10 to 99 inclusive. If either num1 is less than 10 or greater than 99, or num2 is less than 10 or greater than 99, then the method returns false, because at least one of the two numbers is outside the valid range. The operator is a logical OR operator, which means that if either the left or right condition is true, the entire expression will evaluate to true. In this case, if either num1 or num2 is outside the valid range, the entire expression will evaluate to true, causing the method to immediately return false. If both numbers are within the valid range, the code will continue to check for a shared digit. Then we write int digit1 equals num1 modulus 10, int digit2 equals num1 divided by 10 semicolon, int digit3 equals num2 modulus 10 semicolon, int digit4 equals num2 divided by 10 semicolon. Here, if both numbers num1 and num2 are within the range, the method extracts the ones and tens digits of each number using the modulus and integer division operators, and stores them in digit 1, digit 2, digit 3, and digit 4 variables. So here num1 modulus 10 gets the remainder of num1 divided by 10, which gives us the ones digit of num1. For example, if num1 is 23, then num1 modulus 10 will give us 3. Num1 divided by 10 gets the integer quotient of num1 divided by 10, which gives us the tens digit of num1. For example, if num1 is 23, then num1 divided by 10 will give us 2. Similarly, num2 modulus 10 and num2 divided by 10 give us the ones and tens digits of num2 respectively. The extracted digits are then assigned to the variables digit 1, digit 2, digit 3, and digit 4 respectively by extracting the individual digits of the input numbers. We can compare them against each other to check if there is any shared digit between them. Then we write return, open parentheses, digit 1 equals digit 3 or digit 1 equals digit 4 or digit 2 equals digit 3 or digit 2 equals digit 4 close parentheses semicolon. This line of code is checking whether there is a shared digit between num1 and num2. It does so by checking if digit 1, which represents the ones digit of num1, is equal to digit 3, the ones digit of num2, or if digit 1 is equal to digit 4, the tens digit of num2. If either of these conditions is true, then there is a shared digit between num1 and num2. Similarly, it checks if digit 2, which represents the tens digit of num1, is equal to digit 3 or digit 4. If either of these conditions is true, then there is a shared digit between num1 and num2. The operator is a logical OR operator, which means that if any of the conditions are true, the entire expression will evaluate to true. Therefore, if any of the four conditions in the return statement are true, the method will return true, indicating that there is a shared digit between the two numbers. Otherwise, it will return false. Now we create a main method by using shortcut PSVM. Inside this method, we write scanner. Scanner equals new scanner, open parentheses, system.in, close parentheses, semicolon. Here, a new instance of the scanner class is created and assigned to the variable scanner. The argument system.in indicates that the scanner will read input from the standard input stream, which is usually the keyboard. Then write system.out.println, open parentheses, double quote, enter the first number, open parentheses, between 10 to 99, close parentheses, colon, close parentheses, semicolon, int set num1 equals scanner.next, int parentheses, semicolon, system.out.println, open parentheses, double quote, enter the second number, open parentheses, between 10 to 99, close parentheses, colon, close parentheses, semicolon, int set num2 equals scanner.next, int parentheses, semicolon, scanner dot, close parentheses, semicolon. Here, print statement is used to print a message to the console or standard output stream without moving the cursor to the next line. In this code, the message, enter the first number between 10 to 99, is printed to the console. Scanner.nextInt is used to read an integer value from the standard input stream. It waits for the user to enter a value and press enter, and then returns the integer value entered by the user. In the code int set num1 equals scanner do tnextInt, the program waits for the user to enter an integer value and press enter. The entered value is stored in the variable set num1. Similarly, in the code int set num2 equals scanner dot nextInt, the program waits for the user to enter another integer value and press enter, and the entered value is stored in the variable set num2. Scanner.close is used to close the scanner object and release any system resources associated with it. It is good practice to close the scanner object when it is no longer needed to prevent resource leaks. Then we write if open parentheses, shared digit open parentheses, set num1, comma, set num2 double, close parentheses, curly braces, system.out.println, open parentheses, double quote. There is a shared digit between plus set num1 plus double quote and plus set num2, close parentheses, semicolon. Here the if statement checks the return value of the shared digit method with the set num1 and set num2 values as input parameters. If the method returns true, it means that there is a shared digit between the two numbers and the message. There is a shared digit between value 1 and value 1 is printed to the console. Using the println statement, the values of set num1 and set num2 are concatenated to the string message using the plus operator. Then we write else curly braces, system.out.println, open parentheses, double quote. There is no shared digit between plus set num1 plus double quote and plus set num2, close parentheses, semicolon. Here the else statement is executed when the shared digit method returns false, indicating that there is no shared digit between set num1 and set num2. In this case, the message, there is no shared digit between value 1 and value 1 is printed to the console. Using the println statement, the values of set num1 and set num2 are concatenated to the string message using the plus operator. Now we run it. So first it prints message. Enter the first number between 10 to 99. Now we write 12 and press enter. After that, it displays another message. That is, enter the second number between 10 to 99. This time we write 23 and press enter. Finally, it displays that there is a shared digit between 12 and 23. Now we change the value. For this, we run this program again. Now we enter 13 and 26. Here you can see the result, that there is no shared digit between 13 and 26. Now we see the quick summary of this program. So this program checks whether two integers in the range of 10 to 99 have at least one shared digit. The program first defines a method called shared digit that takes two integer arguments, num1 and num2. This method first checks if both integers are within the range of 10 to 99 and returns false if they are not. The method then extracts the ones digit and tens digit of each number using the modulus and division operators, and checks if any of these digits are the same in both numbers. If there is at least one shared digit, the method returns true. Otherwise, it returns false. The main method of the program creates a new scanner object to read input from the user. It prompts the user to enter two integers in the range of 10 to 99, reads the input values using the nextInt method of the scanner object, and then closes the scanner object. It then calls the shared digit method with the two input integers and prints out a message indicating whether or not there is a shared digit between the two integers based on the Boolean value returned by the shared digit method. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Classes and objects. In this lecture, we will discuss about classes and objects. Now we're going to start talking about object-oriented programming. What is object-oriented programming? Object-oriented programming is a way to model real-world objects as software objects, which contain both data and code. OOP is a common acronym for object-oriented programming, and in particular, we'll be talking about classes, which is a fundamental component of object-oriented programming in Java and other languages for that matter. It's sometimes called class-based programming. Class-based programming starts with classes, which become the blueprints for objects. But what does this really mean? To start, we need to understand what objects are. So really, the key to understanding this object-oriented terminology, what I'd like you to do is just have a look around in the area you're sitting in right now. And if you do that, you'll find that there are many examples of real-world objects. For example, I'm sitting here and I can see a computer. I can see a keyboard. I can see a microphone. I can see shelves on the wall. I can see a door. All of these are examples of real-world objects. Now, real-world objects have two major components, state and behavior. The state, in terms of a computer object, might be the amount of RAM has, the operating system it's running, the hard drive size, and the size of the monitor. These are characteristics about the item that can describe it. We can also describe animate objects, like people or animals or even insects. The state might be the number of legs. The conscious state, whether the event is sleeping. In addition to state, objects may also have behavior, or actions that can be performed by the object or upon the object. Behavior for a computer might be things like shutting down, beeping, or outputting some form of sound, drawing something on the screen, and so on. All of this could be described as behaviors for a computer. So, modeling real-world objects or software objects is a fundamental part of object-oriented programming. Now, the software object stores its state in fields, which can also be called variables or attributes. Objects expose their behavior with methods. Well, think of a class as a template or a blueprint for creating objects. Let's take a look at the class. The class describes the data fields and the behavior methods that are relevant to the real-world object we want to describe. These are called class members. A class member could be a field, or a method, or some other type of dependent element. If a field is static, there is only one copy in memory, and this value is associated with the class or template itself. If a field is not static, it's called an instance field, and each object may have a different value stored for this field. The static method can't be dependent on any one object state, so can't reference any instance members. In other words, any method that operates on instance fields needs to be non-static. These class or member fields can be thought of as variables, though it's more common to call them fields or attributes. In this lecture, we'll be looking at instance fields to describe our objects. We'll be describing static members in greater detail later in this section's lecture. So, as it turns out, you've been using classes all along. Now come to practice and open IntelliJ. Here we create a new project, first with name object oriented. And now we create a class file named central class. So for this we right click on src folder and then we click on class option, here given its name, and press enter. Now inside it we create a main method using shortcut psvm. So a question that might come up at this point is, what do we need to bother about classes? Or what benefit do classes give us in our everyday programming? Well, think back to the basic data types that we've worked on, the primitive data types that we've explored so far, such as int, short, and those types of things. They're all basic data types, but they're fairly limiting. There's only so much you can do with them. So a case could be made here that a class could be thought of as a powerful user-defined data type. That's not really correct in the true meaning, but it gives you an idea of what classes are. They're really enabling you to have sort of a powerful user-defined type, like a regular data type. So to take this a little bit further, let's create our first real class. As you can see on the screen, every time we create a new project. And here we've created a project called classes and object. We've been creating a new class, usually one, called central class with capital C. And we generally had a method called main. So now let's create another class. So we'll click down where it's got src for source. Click on that and right click. And we kind of create a class with the name of pen, making sure the first letter is capitalized, as we've recommended previously. When you're creating classes in Java, the first letter should be an uppercase letter. First thing what I want you to notice is this public class pen. That's actually the statement to create a new class with the name pen. Now the UET keyword is an access modifier. This lets us determine what access others will have to this new class that we're creating. We haven't talked about how classes are organized, so let's just look at that briefly before we talk about access. Classes can be organized into logical groupings, which are called packages. We declared package name in the class using the package statement. If you don't declare a package, the class implicitly belongs to the default package. The default package is all we've used so far. Because we haven't yet introduced the package statement, we're not going to get too deep into packages just yet. There's more on them later in this section, but you do need to understand that classes are grouped into packages. To understand access modifiers, a class is said to be a top-level class if it is defined in the source code file and not enclosed in the code block of another class type or method. A top-level class has only two valid access modifier options, public or none. So the word public gives a restricted access to a class. Any code anywhere has access. When we get to Java modules, you'll see that. We can refine this further, but for now, public means any code can access this class. Now, usually, at least initially, anyway we're going to be using the public modifier on the classes we create. And when there is no modifier specified at all, Java by default implicitly allows package private access. This means that classes grouped into the same package can access the class. So that's our class defined, but at the moment it's not very useful because it doesn't actually do anything. Literally, we've created a shell. It's like creating a new blueprint. So remember that the class is a blueprint, F, or an object that we're going to be creating. And in this case, it's like virtually starting out on a brand new blueprint, and we haven't done anything yet. We've called the blueprint pen, but we haven't described anything else about what we're building at this stage. So what we need to do is create some variables that are part of this class. Now the data you've seen in variables used inside a method or code block, and these were called local variables because they were local to or actually belonged to that method or code block, but we couldn't access those local variables outside of the method or block we declared them. Classes allow us to create variables that can be seen or accessible by any code block within that class, but we can also allow access from outside the class itself. When we are designing our class, there are some things we want the public to know, and some things that are necessary for the public to know. We can have a public interface. This is only the information the outside board needs to know to use our class, but we'll also have a non-public interface. This is information we may want to share, but not always and not with everyone. We may need to share some information with our own company and other departments, while other data might need to be shared with our manufacturers and dealers, but not with the public. Java gives us the ability to have this kind of control by specifying different access modifiers for each member in the class. An access modifier at the member level allows granular control over class members. The valid access modifiers are shown in this table, from the least restrictive to the most restrictive. Here you can see that public is still an option for class members like it was for the class, and this means there is a restricted access to the member. We also still have no modifier, which means package, or package private by default, so that any class in the same package can access this member. We could also use private, which is basically the opposite of public, and that's where no code outside the class can use this field or method. And finally, there's the protected modifier. This one also allows package access, but it also permits subclasses to access this member. As a general rule, all your fields should be private, unlike the class where we usually use public. So what we want to make all the fields on the class private. Doesn't this mean that nobody can access them? This practice has a name encapsulation, and it's a key fundamental rule of object-oriented programming. Encapsulation in object-oriented programming usually has two meanings. What is the bundling of behavior and attributes on a single object? The other is the practice of hiding fields and some methods from public access. In general, when we talk about encapsulation, we're talking about information hiding, or hiding the internal workings of a particular object. When we make our attributes private, we can then create methods to access the data, each with different degrees of access allowed as needed. So what we're going to do first is we're going to create some fields for our class. This is going to look familiar to you. It is a lot like the way we've created local variables previously. Well, that's some fields which are characteristics of the pen. So what kind of things might you are interested in when describing a pen? Maybe things like the manufacturer, its color, its type. Let's set these fields and then we'll talk a little about them. Well, that's some fields which are characteristics of the pen. So what kind of things might you are interested in when describing a pen? Maybe things like the manufacturer, its color and its type. Let's set these fields. So we write private string manufacturer semicolon, private string color semicolon, private string type semicolon. So here we've created three fields. There's a fields because they are defined in the class's code block or the body of the class, and not in the method. When we create an object from this class, then the values we assign to these fields represent the state of the object, and like local variables, class variables should have some type of access modifier declared for. If you don't declare one, Java declares the default one package private implicitly. So here we've set the access modifier to be private in all cases, which we've said will help us encapsulate this class. We want to control access to these fields, and this starts by making them private. Later we'll let the methods to access them. The other thing you might have noticed is that we're not actually assigning any values yet. This is because at this point we don't know what these values might be, and they'll likely be different for each instance anyway. If we were creating a real application, we'd likely have a lot more fields, but we'll keep this simple to start with. Let's set a method now that will print out this information about the pen object. We'll call this method describePen and make the method public. This method is not static because we're accessing instance fields. On the class, methods, unlike fields, will often be public because we want to give users a way to interact with the object. Public void describePen opening and closing parentheses, opening curly brace, system.out.println, open parentheses, manufacturer plus double quotes, manufacturer plus, color plus double quotes, plus, type plus double quotes, plus closing curly braces. So we've created our first rule template class called pen, and we've set up some attributes on pen. So the next thing we need to do is we need to create an object from this class, because if you recall, the class is just the template. We need to create an object which will sort of take that blueprint, that definition that we've defined in the class, and instantiate or create an object that we can then start using. So to do that, what we need to do is go back to the central class we started out with, and I'll just click the tab that says Central Class Java. And what we can do in here is we can actually build an object and base it on that pen class. So what we now need to do is create that object. So how do we do that? Did you guess that you'd use the new keyword? So let's do that. First we'll declare a variable of type pen, calling the variable simply pen, and then we'll assign it a new instance of the pen class. Now we write pen equals new pen, opening and closing parentheses, semicolon. Then we write pen.describe pen, opening, closing parentheses, semicolon. So now what happens? And if we run that, we get null manufacturer, null, null. So what's happening here? When do we get null? When we were expecting manufacturer, color, and type. Notice a special keyword in Java meaning the variable or attribute has a type, but no reference to an object. This means that no instance or object is assigned to the variable field. Fields with primitive data types are never null. So what is the manufacturer, color, and type? Pull all of these. Fields were declared with the string data type, and we haven't assigned values to them. We know from previous lectures that strings are really objects, not primitive data types. So Java assigned each a null reference. The other thing I want you to notice about the output we got was that manufacturer was printed with the value null here. So how is that possible? We didn't set manufacturer to any values in our class, but we didn't get any errors when running this code. And now we're seeing another difference between local variables and fields declared on a class. And this is that a field with the primitive data type will get assigned a default value by Java. Fields some classes and assign default values intrinsically by Java if not assigned explicitly. So because we didn't assign any values to our fields, Java assigned some values for us by default. Java will set any numeric primitive type to a 0 for double S and floats. The numeric literal, which is implicitly assigned, is the decimal number 0.0. The building field is assigned false by default, and any other type will be null. So now let's assign some of our own default values to these attributes. So go into the pen class, and here we assign Edison to the manufacturer, blue to the color, and gel to the type of pen attributes. This means that every object that's instantiated will get assigned the default values we declared here instead of Java's implicit values. And now running our code in centralclass.java. Now we can see the output that is Edison, manufacturer, blue, and gel. So every pen object we create will have these values by default. But that's not what we really want either. How do we can set the manufacturer, color, and type of our pen each time we create a pen object? Since we made these fields private, we can't use the dot notation with the variable name to set the value. Let me show you what I mean. Let's try accessing these fields directly in the main method. Now we write pen.manufacturer equals double quotes Garwood semicolon, pen.color equals double quotes black semicolon, pen.type equals double quotes fountain semicolon. You can see when we try this, we get errors on all three of those lines. We've defined these fields as private on the pen class, and because of that, we can't set the values on any pen object we create this way. So let's comment this code out for a moment. We also can't access those values directly in an expression. For example, we just print that data out in the main method of this central class. So we write system.out.println opening parentheses double quotes manufacturer equals plus pen dot manufacturer closing parentheses semicolon plus pen dot manufacturer closing parentheses semicolon system dot out dot println opening parentheses double quotes color equals plus pen dot color closing parentheses semicolon system dot out dot println opening parentheses double quotes type equals plus pen dot type closing parentheses semicolon. Again, we get compiler errors saying that these fields have private access and our central class isn't allowed to access them. Over that described pen method, how does outside code get access to this data? We could make all of these fields public or package, but we've set this as bad practice. So we're not going to do that. What we're going to do is allow access to this data. Either to set it, we'll get it through methods on this class. These are a special set of methods called getters and setters. So what getters and setters are? The getter is a method on a class that retrieves the value of a private field and returns. The setters are a method on a class that sets the value of a private field. The purpose of these methods is to control and protect access to private fields. Another important aspect is that the getter and setter method signatures are part of pen public interface, but the attribute names and types are. This means that we can change things internally, like the name or type of an attribute, but as long as we use the same getter and setter method, these changes should have no effect on code that uses our class. Our internal changes are hidden from our users. The getter method usually just returns the value of a private attribute. It's usual to name a getter method with the get prefix followed by the field name in lower camel case, but this is not required. You could have getter methods 3 attributes that are not really declared on your class, but that are derived in some way. A setter method may simply just assign the argument passed to the attribute, but it often contains code to validate data, check additional security requirements, ensure immutability of the field value, or any other code required to protect and validate an object state. It's usual to name a setter method with the set prefix, followed by the field name in lower camel case. But again, this is a matter of 3. There may be many cases where we won't have any set of methods for some of our private fields. Maybe this is data only needed within the class itself and doesn't need to be exposed to the outside world. So let's first start again a method. Going back to the pen class, we'll add a method which will get manufacturer on using a method. Public string get manufacturer opening and closing parentheses, opening curly braces, return manufacturer semicolon. So this method is public, but notices we don't use the word static here when writing methods that use non-static fields. Your method can't be declared static. We just return the field name manufacturer, even though manufacturer is declared on the class, to create the other kind of methods. We could copy and paste this code 2 times and change the name and the attribute returned in each instance. But in general, you won't really be manually typing in the code for you getting methods until IJ has features to generate code for you, including one to create a setter getter methods. Let's do that for the next 2 attributes. I set my cursor under that first getter method, and then I'll select the code menu item, and then generate, and if you click on that, you'll see there's a lot of options. We'll select getter. Numbers of attributes are listed here. that don't already have getters. So select the remaining two by holding Shift and pressing the down arrow key. And then we have two new public methods, getColor and getType. So let's use these getters in our main method. In each println statement, I'll change the code to use the corresponding getter method. When I delete the field name and until ij, I can pick to get a method from the list displayed. And you can see we've eliminated our errors in the main method. Let's run this now. And you can see we can now use the manufacturer, color and type in our own output string. We also still calling the describe pen method. That gives us all the information. So in this lecture, we've talked about encapsulation, getters, and setters, and we added getters for our three private fields, both manually as well as using IntelliJ as generation feature. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Understanding of reference, object, and instance. In this lecture, we're going to go over and discuss references, objects, and instances in an effort to clear up any misunderstandings. By now, you've probably noticed that we use the words reference, object, instance, and class quite a lot when talking about Java code. These new concepts may well be confusing at first. So in this lecture, I'm going to try and go through the process and show you exactly what each of these words means in the context of Java programming. You might remember in earlier lectures of the course that we use object and instance interchangeably, and that we create an instance or object using a class. These new concepts may well be confusing at first, so let's talk about them. Let's use the analogy of build an office to understand classes. Now, class is basically a blueprint for the office. Do you think the blueprint we can build as much office as we like based on those plans? So, thinking back to the physical world, we use the plans for the office to build many offices that have the same full plan. Each office we build, in other words, going back to programming terms, each office instantiate using the new operator as an object. This object can also be known as an instance. Often we'll say it's an instance of the class. So we would have an instance of office in this example. Getting back to the physical world, each office we build has an address. It's built at a physical location. In other words, if we tell someone where we work, we give them our address, perhaps written on a piece of paper. So that piece of paper with the address on it. This is known as a reference. Then we can copy that reference as many times as we like. But there is still just one office that we're referring to. In other words, we're copying the paper that has the address on it, not the office itself. Or we're writing that address on another piece of paper. Now back to programming terms. We could pass references as parameters to constructors and methods. Let's not just go a bit deeper to make this clearer. So we've got some code on the screen now. Now on the left-hand side, we've got the class office with instance variable, also known as a field called name. Now on the right-hand side, we have the main class with the main method. Now this code in the main method is creating instances of the office class, changing the name, and printing out the result. So let's actually go through line by line and see what happens when this code is executed. So looking at this first line that I've got highlighted in red on the right hand side, office my office equals new my office, opening parentheses and double quotes, nixware closing parentheses, semicolon. This code creates a new instance of the office class. So remember, office is a blueprint, and we're assigning it to the myOffice variable. So in other words, it's a reference to the object in memory. Then you can see that hopefully on the left hand side, And then it makes a bit more sense there. My office is the variable. We're creating a new instance of the office class and assigning it the name Nixware. So this next line, then I've got highlighted as another office equals my office. Well, that creates another reference to the same object in memory. So what we've got now is two references pointing to the same object in memory. So there is still one office but two references to that one object. So in other words, we've got two pieces of paper with the physical address of where the office is built, written down if we came back to a real-world example to make that clearer. So next, on the right-hand side, I've got two print statements highlighted. So they print the value of the name variable for my office and also another office. Now, in this scenario, both will actually print Nixware, and that's because again, we've got two references to the same object. And again, you can see that on the left-hand side there. Hopefully that image showing both references to the same office, which is Nixware, makes that clearer as to how this is actually working. Alright, so this next line I've highlighted here. Another office dot set name Nixware Consulting Company. Well, that's calling the method set name and setting the name to Nixware Consulting Company. Now to the left, you can see that both my office and another office now have the same name. So why is that? All remember that we've got two references that point to the same object in memory. Now, once we change the name of one, both references still point to the same object. So consequently, they both got the same value of Nixware Consulting Company in this example. Alright, so we've got a couple more print statements here, which I've highlighted. So these two print statements are printing the same name. Both are printing Nixware Consulting Company because again, we've got two references that point to the same object in memory. And again, you can see that defined with the arrow on the left-hand side of the image when instance, pointed to by two objects. So moving on, what we're doing now is with that next line that's highlighted on this slide. Office new office equals new office. We're creating another new instance of the house class, this time with the name set to again Nixware. So now we've got two objects in memory, but we've got three references. And those references are my office, another office, and our new office. Now the variable or reference new office points to a different object in memory. And that's the one we just instantiated using the new keyword here. The my office and another office point to the same object in memory. The previous office we created at this point. So I've highlighted this statement. Another office equals my office. So what we're doing here is we're assigning my office to another office. So in other words, we're really dereferencing another office. And it will now point to a different object in memory. Previously, that was pointing to an office that had the Nixware Consulting Company name, but now it's pointing to an office that's got the Nixware name again. So in this scenario, we still have three references and two objects in memory. But my office points to one object, while another office in my office now point to the same object, which has the again Nixware name in memory. And finally, we've got those last three print line statements. The first will print Nixware Consulting Company, since the my office variable or reference points to the object in memory that has the Nixware Consulting Company name. The next two lines will print again Nixware, and that's because another office and new office point to the same object in memory. So keep in mind that in Java, you always have a reference to an object in memory. There's no way to access an object directly. Everything is done using that reference. Now we see a quick summary. So reference A reference is a variable that points to an object or an instance of a class. When you declare a variable of a particular type, such as string or my class, you are creating a reference variable. The reference variable holds the memory address of the object or instance of the class and not the object itself. Object. An object is an instance of a class that is created at runtime. It is a concrete entity that occupies memory space and has state and behavior. An object is created using the new keyword, followed by the class name. Instance. An instance is a single occurrence of an object. Every time you create an object using the new keyword, you are creating a new instance of that object. So, as a result, a reference is a variable that holds the memory address of an object or instance. An object is a concrete entity that has state and behavior, and an instance is a single occurrence of an object created using the new keyword. I hope you learned something useful in this lecture as well, and I'll see you in the next one. Introduction to Java.lang.Object. In this lecture, we will talk about Java.lang.Object class. Now it's time to come back to inheritance. So, in the last couple of lectures, we introduced you to inheritance and how it works with the class hierarchy. We talked about the base class, also called the superclass, and subclasses. We demonstrated overriding methods, and we gave you a quick look at how inheritance plays into polymorphism in Java. Well, it turns out in Java, we've been using inheritance all along without even knowing it. This is because every class you create in Java intrinsically extends a special Java class. This class is named Object, and it's in the Java.lang package. That's confusing a class called Object. Let's see what Java has to say about this class. We used to link to Java application programming interface API for this class. This is a class called Object. Class Object is the root of the class hierarchy. Every class has Object. That's a superclass. Objects, including arrays, implement the methods of this class. Whether you knew it or not, your classes were extending this class Object. They all inherit from Object. And what that means is all of your classes have functionality built in that you can use or override the minute you create them. Let's explore the methods on Java.lang.Object. And here you can see some of the methods on object by clone and equals. And also here is one we just showed in the last couple of videos, that toString method. Every class we create or use is automatically inheriting from this Java supplied class called the Object class. Let's see an example. For this, open IntelliJ. Now we create a project named Java.lang.Object.